Good morning, everybody. My name is Dr. Ghulum Baqiri. I'd like to welcome you all to this GIS Day 2023. We'll start with congratulating the Kingdom of Bahrain for our National Day, congratulating our leadership, the people of Bahrain, as well as everybody on this National Day, holidays which are coming in a few days. I would also have I would like to announce that we are celebrating as Microcenter in few months, in March 2024, 40 years of, we'll call it success. And we owe this success to our clients, employees, as well as partners, both locally here and internationally. I would like to thank, we have as you can see from the agenda, we have about 8 topics, 8 presentations. This is why we had to shorten each of these to between 20 and 30 minutes. I would like to thank our organizations who contributed, namely IGA, Ministry of Transportation, Telecommunications, yes, and the National Science Agency in Bahrain, and the Ministry of Works for their presentations. We would like also to thank our partners in Autodesk and in Esri for their presentations. Finally, I would like to thank our internal team headed by Mr. Adouri, who will be doing the last presentation in this GIS Day, for organizing this event and putting all of this together. We will have a short video by Jack Dangermond, I think it's a couple of minutes, welcoming you to the GIS Day. After that, our Dr. Abu Bashar will take over and introduce our speakers and the topics one by one as we go along during this day. I wish you a wonderful GIS Day and a fruitful one, hopefully. Please go ahead.
Hi, my name is Jack Dangermond. I want to invite all of you to participate in the 2023 GIS Day event. This day is during Geography Week, and it's being held with little events all over the world, thousands of them. Organizations who have GIS units are having open houses to show the work that they are doing and how it's contributing to their organization and beyond. There's so many things to do. Map exhibits, a little teach-in to executives or to school children or to others. Listen, geography and GIS are increasingly valuable and important in organizations. One of our big challenges is that people don't actually understand it. They don't understand the kind of value that it offers and the kind of ways that it can bring organizations together to do more holistic approaches to problem solving and, well, just even communication to others. I invite you to participate, and Esri will support you in various ways. I'm looking forward to participating myself. See you on GIS Day.
Uh, Very good morning to all of you. Thank you very much to all present. I, Dr. Abu Bashar, Senior Business Development Consultant, Microcenter Groups. And I am welcoming all of you again on the behalf of all our team and participants. So like it was mentioned, and it is very evident from our agenda that today we have exciting sessions on digital twin, BIM application of GIS in varied industry. And the speakers for today's program are going to enlighten us with their exceptional expertise in their industry. So without taking much time, I'm going to introduce our first speaker for today. And of course, it is indeed my pleasure to introduce Mr. Fatih Sabu Rashid. And seriously, we are honored to have him as our guest speaker today. And Mr. Fatih is a renowned professional and chief Spatial Info and Remote Sensing Information and E-Government Authority. And Mr. Fatih has achieved many accomplishments in their field, and he is one of the driving forces among the adoption of technology in this particular industry. So please join me in welcoming Mr. Fatih. Sir, very good morning. So please continue with your presentation.
Thank you, Dr. Abu Bashar, for the nice introduction. Appreciate it. So let me share my screen. I will stop the video so that it will not affect the presentation. And let me share. Let me see. Can you see my screen?
Yes.
Excellent. Excellent. So let's start. Bismillah ar-Rahman ar-Rahim. Thank you so much for attending this presentation. And this presentation, the title of which is Digital Twins, the Road to Smart Cities. And in this presentation, we will explore the transformative potential of digital twins, and we will delve into the, sorry about that. Yes, we will delve into the concept of digital twins, their role in the urban planning and management, and the tangible benefits they bring to citizens and the communities. But first, let me give you a brief outline of the presentation. I'll start off with an introduction, and then I will explain what is meant by digital twin. And next, I will outline the benefits of digital twins and give examples of their applications. And then I will focus on some real-world case studies. And last, I'll be talking about the challenges and that faces digital twins. So buckle your seatbelts and let's start. I will start off with this short video that explains what is a smart city, what is the benefit of a smart city, and the concept behind it. Start from here.
How would you envision the cities of the future? Picture this: urban landscapes transformed by smart cities, where technology and data collection revolutionize our everyday lives. The future of cities is not just about buildings and roads, it's about creating smarter, more efficient, and more sustainable urban environments. Smart cities come with a wealth of benefits. Imagine a city that breathes efficiency, where technology and data collaborate to manage resources effectively. From traffic lights to power grids, every element is optimized, reducing waste and enhancing sustainability. Now imagine this city is also designed to minimize environmental impact. Through smart waste management and energy-efficient buildings, it's a city that respects and protects Mother Earth. But it's not just about efficiency and sustainability. Smart cities are about enhancing your life. With digital services that simplify daily tasks, improved security through smart surveillance, and better healthcare through telemedicine, living becomes a seamless experience. In a smart city, every element works together to create a seamless, efficient, and sustainable urban environment. Imagine a city that knows what you need even before you do. Picture this: smart cities using predictive analytics and real-time data, not just to react, but to anticipate your needs. A traffic jam on your commute? The city has already rerouted you. Power grid overloaded? The city balances the load before it becomes a problem. And public services? They're dispatched just where they're needed, when they're needed. Smart cities represent a new era of urban living, where technology and data drive efficiency, sustainability, and quality of life. Smart cities are not just a vision for the future, they're becoming a reality today. From Singapore to San Francisco, cities are harnessing technology to revolutionize infrastructure, enhance quality of life, and foster sustainable growth. Smart sensors, predictive analytics, and integrated platforms are transforming urban landscapes, creating environments that are more responsive, resilient, and resource efficient. As we embrace the potential of smart cities, we're not just building better urban environments, we're shaping the future of our societies. How would you envision the cities?
So now, since we have known what a smart city is, let's move on to digital twins and how the need for them began. Now, in today's rapid evolving world, cities are faced with challenge of optimizing resources, enhancing citizen services, and ensuring sustainable growth. And with cities are, as we know, the engines of innovation. They are the incubator of economic growth and social progress. However, they face increased challenges in sustainability, resource management, and citizen well-being. Now, digital twins emerge as a beacon of hope, offering paradigm shift in urban development and management. So cities are not just physical structures, they are complex ecosystems that encompass people, infrastructure, services, and the environment. Effectively managing these interconnected elements is crucial for sustainable and resilient urban development. And digital twins, of course, offer a groundbreaking approach to address this challenge. And next, I will explain what is meant by a digital twin. So a digital twin is a virtual representation of a physical object or a system mirroring its real-world counterpart. It continuously collects and analyzes data from sensors, IoT devices, and other sources. It incorporates different systems like BIM, again sensors, 3D data, GIS, AI, and so on. This data-rich representation provides real-time insights and enable simulation and modeling. Digital twins are not mere static replicas. They are dynamic entities that evolve along their physical counterparts. They serve as a virtual laboratories that gather and analyze vast amount of data, providing insight into the behavior and performance of complex systems. Next, I'll be talking about the benefits of digital twins. There are so many benefits for digital twins. Among them, enhancing urban planning and decision making. Digital twins provide a vital and provide a virtual sandbox for simulating and evaluating urban development scenarios. They provide optimized resource allocation, so they enable real-time monitoring and optimization of resources such as energy, water, and transportation. They provide also improved infrastructure management, in which digital twins facilitate the predictive maintenance and anomaly detection, reducing downtimes and enhancing the infrastructure. Also, they enhance the citizen engagement. They can be used to create immersive virtual experiences, enabling citizens to interact with urban planning projects and provide feedback. Go back. So therefore, digital twins empower cities to make informed decisions based on real-time data and insights. They optimize the resource allocation and enhance the infrastructure management and promote citizen engagement and leading to a more sustainable, efficient, and livable urban environment. Next, I'll be going and explaining some of the applications that are used or that is used where digital twins are utilized. We'll start off with transportation. Nowadays, lots of cars are having lots of sensors, and the advancements of those sensors are quite staggering, with autonomous vehicles starting to be adopted. And with those vehicles, different sensors are being sent to control centers, reporting the status of the vehicle. So digital twins can optimize the traffic flow congestion. You have your road sensors that can send those signals to the control station or control system, and it will where the condition of the road is being monitored, and if there is a obstruction in the road, an incident or an accident, then measures can be taken to mitigate this. So also it can be used to reduce congestion and improve the public transportation routes. Another application of digital twins is in the energy management sector, where they can be used to optimize energy consumption, reduce the carbon emissions, and promote renewable energy and integration. Another application is in public safety. Digital twins can enhance the emergency response coordination. They can be used to improve the disaster preparedness and facilitate crime prevention strategies. Another application of digital twinning is in environmental monitoring. They can track the air and the water quality and relay that information to a smart city system. If there is a disaster, there is a pollution, a radioactive leak in the atmosphere, then those areas can be identified, and certain plans can be used to mitigate that and to lay out an emergency response plan. It can be used to monitor pollution levels, and inform and influence the environmental management decisions. So digital twins are not limited to a single domain. Their applications span across various aspects of the urban life. They revolutionize transportation, optimize energy usage, enhance public safety, and promote environmental sustainability, transforming cities into a holistic and interconnected ecosystems. Next, I'll be talking about three real-world examples of implementation for digital twins. Those implementations have varying degrees of being implemented. I will start off with Singapore. And with Singapore, the Singaporean government established a portal or a platform called the Virtual Singapore platform. It's a 3D digital replica of Singapore built on topological as well as real-time dynamic data. Now, the system is geared to be the country's authoritative platform that can be used in simulations and virtual tests of new solutions to urban planning problems. Singapore, the Singaporean government has spent so many years establishing the base, the cornerstone for the system in the sense of BIM data. They have gone through quite an experience with that. And BIM is the backbone. It's the basis in which a smart city is built. And they've accomplished quite an impressive establishment of BIM data. Next, I'll move to Abu Dhabi. And Abu Dhabi, just last year, Abu Dhabi Department of Municipalities and Transport has launched the Abu Dhabi Digital Twin project. The project will enable the use of 3D augmented reality, and that is to better facilitate and support decision-making process, as well as integrating advanced technologies such as aerial photography, LiDAR, scanning. And last but not least, in Helsinki, there is a project called the Helsinki Region Digital Twin, and it's one of the world's longest running digital twinning programs. I believe they've started it in the mid-80s, if I'm not mistaken, and over the last 3 decades, it has pushed the envelope with early adaptation of computer graphics design, computer-aided design, and 3D city mapping, and later full-scale digital twins. Along the way, it experimented with many ideas, and many of which are showing actual dividends for citizens, planners, and local businesses. So these were some cases, real-world case study demonstrating the practical implementation of digital twins in cities worldwide, highlighting their transformative impact on urban planning, infrastructure management, and citizen services. They serve as a testament to the potential of digital twins to revolutionize the way we manage and experience cities. So what are the challenges that need to be considered? Of course, navigating the road to implementation. So first challenge is data security and privacy, protecting the sensitive citizen data, and ensuring the responsible data handling and are prominent. So this will, of course, will need to have mandates, clear mandates implemented for this. We have the interoperability and standardization, ensuring the seamless data exchange between different systems and platform is very crucial for an easy operation of a smart city and a digital twins. You have different components, different systems, data is coming from different sources. They need to work together seamlessly in order to have an effective digital twin and a smart city. Technological expertise and capacity building. So that's another challenge. Cities require the necessary expertise and infrastructure to effectively implement and manage digital twins. And so capacity building is very important to reach the level of expertise needed to create and maintain such complex systems. And public acceptance and trust, that's another issue also. So fostering public awareness and building trust is very important for the successful implementation of a digital twins. And with this, I've reached the end of this presentation. I would like to thank you all for your attendance. And I would like to apologize for the hiccups in the beginning of this presentation. It's the first time I'm sharing a video, so I forgot to press that button to share the sound of the video. And I would also like to take this opportunity to thank Dr. Kingdom of Bahrain, Microcenter's CEO, and Microcenter team for organizing this wonderful gathering. Many thanks. Thank you so much.
Thank you very much, Mr. Fatih, for wonderful presentation about the role of digital twins in smart cities. And it was really worthy to note when you talk about that digital twin is a kind of beacon of hope in terms of optimize the planning, operation, finance, and decision making to reduce carbon emission or construct large projects in a single and simple way in either transportation. Then we talk about energy management, public safety, and environmental monitoring. So this is something that is really exciting. And we hope that the coming future, we will see that our kingdom is going to adopt all these things in order to be in the forefront when it comes to adoption of technology. So thank you so very much, sir. Have a great day. Thanks a lot.
Thank you, my dear. Thanks a lot. Bye-bye.
And now our next speaker is Mr. Muhammad Abdullah Tolifat, the Chief GIS Processes Analysis, Information and E-Government Authority. And Mr. Abdullah is one of the renowned professionals in the domain of GIS and have been instrumental in exploring and adopting best-in-class GIS processing technologies in the Kingdom of Bahrain. So without taking much time, I would like to welcome Mr. Muhammad Abdullah Fatih. So sir, please proceed with your presentation. Thank you for your time.
Thank you, Doctor. So thank you in the beginning for all of the attendance and for giving us this opportunity to share with you our demonstrations and to celebrate all together this special day for us. So just 1 second, let me share the presentation. So can you see my screen? It's okay?
Yes, sir, it is available. Thank you.
All right. Thank you. So we are going to talk about the potential of BIM in small cities and infrastructure permits. I believe my colleague has already demonstrated a nice presentation about small cities and the digital twins. So this is somehow related to the small cities and the BIM technology. So in the beginning, as an overview about the presentations that I'm going to take, I'm going to talk about an introduction about BIM and small cities. We are going to have a brief about the benefits of BIM and infrastructure permits, some use cases for BIM and infrastructure permits, and some of the case studies that has been done by some of the countries which is leading this technologies. We are going to go also on some of the challenges of implementing BIM adaptation and some of the key practices and how to overcome these challenges, the future of BIM, and I'm going to share with you also a short video. The last thing is the conclusion. So as a definition of small cities, I believe my colleague has already shared the video and he talked about small cities. So it's basically to integrate information and communication technologies and Internet of Things solutions to optimize the efficiency of urban services and enhance the quality of life for the citizens. So it's basically collecting all of the data which is available, so whether it is from mobile or from internet, from the users, and using it to enhance the quality of the lives of the citizens. What are the benefits of having an efficient infrastructure management in small cities? There are 5 benefits, or maybe 5 benefits. One of them is elevating the quality of life, economic growth and innovation, ensuring the sustainable urban development, enhance resource utilization, improve the service delivery. Cities, by having these factors, can achieve greater efficiency in managing their infrastructure assets and leading to range these benefits. So as a definition of BIM, BIM is basically the building information model. It's a digital representation of the physical building or infrastructure assets. BIM is considered these days as a latest trend in infrastructure data, and it's basically changing the way how we are dealing with and managing the infrastructure project in terms of how to get the permit, how to deal, how to produce these plans for the projects, and how to get the approvals. So BIM models can be used in many things. It can be used to improve the collaboration, reduce the errors, and enhance the decision making, and of course, promote sustainability. So 4 of the main benefits of having BIM and infrastructure permits is to improve the collaboration between the entities and the stakeholders. BIM can facilitate the collaboration between different stakeholders involved in the permitting process, such as the designer, engineers, and government, and all the stakeholders which are involved in this process. BIM also can reduce the errors because it will help you to identify and eliminate the potential conflicts and errors into the design stage, rather than instead of waiting until it is submitted and later getting these comments. It will enhance the decision making. BIM can provide the designer and engineers and the government and all the stakeholders with the information they need to make the better decision making. It will promote sustainability, because BIM can be used to design and construct more sustainable infrastructure projects. So these are the main benefits of BIM, using BIM infrastructure permits. So how BIM can streamline the infrastructure permit approval process? BIM can improve the stakeholder collaboration and communication. It will provide a real-time visibility of project progress, especially when it comes to building permits. It will enhance the way how we are following up on the construction of the buildings, or even the projects which is done, the underground projects and all the related projects. It will enhance the follow-up of these projects, since it will provide a real-time progress. It will provide also an accurate and detailed project documentation, data-driven analysis for permit evaluation, and it will help in clash detection and conflict resolution. So these are some example or use cases for BIM, how BIM is used in infrastructure permits. In terms of clash detection, BIM can be used to identify potential clashes between different elements of an infrastructure permit, such as pipe, ducts, electrical wires. So as an example, if we compare it with the current way of dealing with infrastructure permits in terms of waiver or GSM or even planning permission, currently the designers or the stakeholders or whoever is going to apply for these permits, they are designing and doing everything in-house and then applying on the system and getting the feedback from the stakeholders, whoever will approve these requests. So usually they will design it, they will have some of the data which will show them whether it is conflicting with other, infrastructure, but using BIM will change the way how these things are dealt with currently, because it will have sort of assigned rules and automated approval even before applying. So our aim later on, or the BIM aim, will help even maybe to automate these approvals. In the future, I believe these stakeholders might not receive any requests anymore. The system they will just assign these rules in the system, and the system will approve these requests on behalf of them. So in terms of code compliance checking, BIM can be used to check that infrastructure projects complies with all the applicable codes and standards. So as I mentioned, all the codes and standards will be implemented in the system, and the system will automate this checking. Energy modeling, BIM can be used to model the energy performance of an infrastructure project and identify the potential design changes that could improve energy efficiency. So it will also help in the energy efficiency, and it will ensure the sustainability assessment, since BIM can be used to assess the sustainability of an infrastructure project and identify opportunity to reduce its environmental impact. So these are some of the case studies, some of the leading countries which started BIM earlier. One of them is the city of Los Angeles. We can see that in one of their projects, they have reduced the approval time to 50% in a new office building. City of Singapore, my colleague has already mentioned an example about City of Singapore. Singapore has started implementing and adopting BIM long time back. They consider as a leading country in this technology, and they have currently mandated all the new building permits and designs on using BIM. As for City of Tokyo, in one of their projects, they use BIM and reduces the approval time to 40%. So from these case studies, we can imagine how BIM can affect and how it is changing the way of the approval and reducing the time and the efficiency of infrastructure permits. So, of course, any new technology, there are challenges also which is coming with it. So implementing BIM is the new way, or let's say that is the future. But there are also challenges with implementing BIM. One of them is the cost. Currently, BIM softwares are very expensive. It's complicated also because models there are many models, and managing these models is a little bit complicated. And when it comes to data, there are many softwares for BIM, and still there are some of the open data, let's say, or the data which could be used in BIM, but still it requires more, maybe it requires more. Maybe while moving with it, we will find more data and standards which will be used in BIM. So this is one also of the challenges that is faced. Lack of standards. There are certain standards, but maybe we can see that each country has their own standards so far. But I believe within these years, we'll find some standards which will be international for all these countries. The change management as well, because changing from the traditional way until BIM requires also the stakeholders to be also cooperated, and they need to all work together to ensure the change management to use this new technology. And this is something I believe normal with any new technology. So there are also legal changes which require to be considered. So this is also one of, consider the main challenges in the BIM adaptation. So these are some of the key practices, or let's say how to overcome these challenges. There should be a clear project objectives and collaboration framework, adequate training and support for stakeholders. As I mentioned, it's a new technology, so all the stakeholders, whoever is going to use this technology, has to be aware of this technology. There should be a training for all the users and stakeholders. There should be a data standard and protocols cleared for using this standards and this new technology. Continuous monitoring and evaluation. So when we talk about the future of BIM and infrastructure permit, we'll talk about four things. As BIM adaptation increases, the cost of BIM software and training will be decreased. So as we mentioned in the challenges, that it's currently BIM adaptation is very maybe costly, but while using it later on, it will be decreases. BIM is becoming increasingly adopted by government agencies, which is very good, because the government is starting adopting this technology, and then of course the private companies is also going to use it after having correct standards and changing the legal protocol. It will be used by all. So open BIM standards are being developed to improve data and improve the standards of this data. The government agencies are developing BIM guidelines and standards. And this is what we have seen in the case studies, whether it is in Singapore or Los Angeles. It first begins with the government agencies with developing these guidelines and standards, and then it will be adopted by all the other stakeholders. So this is a short video for 3 minutes I would like to share with you. Just allow me just to enable the sound. Just 1 second. Share it again.
Imagine a city that breathes, adapts, and evolves, just like a living organism. This is not a scene from a sci-fi movie, but the promise of smart cities, powered by the revolutionary technology of Building Information Modeling, or BIM. BIM is not just a fancy term for 3D design. It's a process that fosters collaboration, enhances efficiency, and reduces costs. It's a powerful tool that integrates various data in a single, cohesive model. This technology is the key to unlocking the potential of smart cities, making them more sustainable, more efficient, and more livable. Take the case of Singapore, a city-state known for its skyline of futuristic buildings and its commitment to smart, sustainable growth. In 2021, the Singapore government mandated the use of BIM for all major construction projects. This was not just to create visually stunning buildings, but to streamline the entire process of urban planning, from design to construction to maintenance. Through BIM, Singapore was able to integrate various aspects of urban planning, such as traffic management, waste disposal systems, and energy usage, into a single comprehensive model. This allowed stakeholders to visualize the impact of their decisions in real time, reducing errors, saving time, and ensuring that the final product met the highest standards of sustainability and livability. BIM also played a crucial role in the permitting process. It enabled the authorities to review and approve plans more quickly and accurately, cutting down the time it took to secure a permit from months to weeks. This, in turn, accelerated the pace of development, allowing Singapore to meet its ambitious goals in urban development. BIM's benefits stretch far beyond the construction phase. With its capacity to integrate real-time data, BIM holds the power to revolutionize city management. It can forecast when a structure requires maintenance, streamline energy consumption, and even anticipate traffic flow. Essentially, BIM is capable of transforming a city from smart to intelligent. But BIM isn't merely a tool for designing buildings. It's a catalyst for city transformation, greatly streamlining the infrastructure permits approval process. By consolidating all necessary data into a single model, BIM enables a more efficient project review, reducing the time required to obtain necessary approvals. This accelerates the overall development process, making it easier to achieve project deadlines and objectives. It stimulates collaboration, boosts efficiency, and lowers costs. This robust technology has the potential to make our cities more efficient and more livable. Singapore's success story serves as a testament to the power of BIM in smart city development. As more cities globally adopt this technology, we can anticipate a future where our cities aren't merely habitats, but ecosystems that enhance our quality of life. The future of smart cities has arrived, powered by BIM. The opportunities are boundless and the benefits are tremendous. Now is the time to welcome this technology. After all, the cities of the future won't just be constructed, they'll be modeled. Imagine a city that breathes. Imagine.
So, as a conclusion, we can understand that. So, as a conclusion, we can understand that BIM has a great impact in changing the way of dealing with infrastructure projects and the permits which is related to these projects. BIM can improve the collaboration and reduce the errors, enhance decision-making, and promote sustainability. As BIM adaptation increases, the benefits of BIM will become even more apparent. Thank you very much for giving me this opportunity. So I think I'm done. Thank you for all the attendance.
Thank you very much, Mr. Muhammad, for your remarkable presentation and your insights on potential of BIM in smart cities, infrastructure permits were really truly enlightening. And I was particularly, looking into some perspective that you have discussed about, like, the improved collaboration, the reduced errors, enhanced decision making, and the sustainability in all the design, construction, and maintenance. So basically, with the adoption of BIM for the infrastructure permits, the cities are going to be intelligent from a smart. So thank you so very much for giving us this thought-provoking session. Thank you, sir.
Thank you. Thank you once again. Thank you. Thank you.
Now, our next speaker is from Ministry of Transportation and Telecommunication. And we have today Ms. Shaima Ali Al-Banna. She is a civil engineer. And we have Mr. Yaqub Yusuf Haji. He's also a civil engineer from Ministry of Transportation. And they are going to make us really deep dive into the application and integration of GIS in land transport database. So this is something that is, really need of the hour, that how we are going to make the database in terms of land transport and how it is going to be efficient for the overall management of this. So Ms. Shaima and Mr. Yaqub, please go ahead with your presentation.
Yes, hello, assalamu alaikum.
Alaikum assalam wa rahmatullah wa barakatuh.
Yes. We'll be sharing our slide now. Is it visible?
Yes, ma'am. Yeah.
Oh, okay then, thank you. First of all, we'd like to thank Microcenter for inviting us to this event and for letting us present about our topic. And once again, thank you for the introduction. Our topic will be, as mentioned, application integration of GIS and land transport data. So we're going to kickstart our presentation with a brief introduction about land transport and how we've come to apply ArcGIS for our existing database. So first of all, land transport is one of the four main sectors under Ministry of Transportation and Telecommunication. It is basically responsible for developing and regulating all kinds of land transport systems, such as the public bus, taxi, and we have also transport of goods and people, and also even micromobility. So from this brief, you can deduce that our vision is to provide sustainable transportation system. And our mission is also to provide an integrated and sustainable transportation system for goods and people. Based on these two, we've come up with 4 strategic goals, 2 which are of like no importance to us as of now for GIS. And the 2 main goals are basically related to our application of GIS, which is development of the infrastructure and to increase the efficiency of operation and services. So how do we increase the efficiency of the operation and services and develop infrastructure using the ArcGIS? These 2 goals has created the need for creating and maintaining and updating the public transportation infrastructure database.
So as my colleague Shema mentioned in the previous slide, MTT has created a database for all land transportation and infrastructure since 2015, and that includes the bus stop, the bus shelter, bus pole, our bus terminals, and we have also the taxi ranks, taxi pylon, and for the micro mobility, we have the cycle lane and all other projects which are related to the land transport sector. So this database has been created by using the microstation, which shows the exact location of each asset on the map. And also we have the Excel sheet, which shows the details of each asset separately, such as the name, code, type of the stop, and also the operation dates, the construction date of the stop, and the number of routes passing for each bus stop. And the last thing is the photo for each stop. So by having this, MTT can conduct a routine and preventative maintenance on the assets. And we can conduct inspection on our assets, update, maintain, and manage our data, perform a gap, and we can also perform a gap analysis, establishing asset history, and eliminate data redundancy.
Continuing from where my colleague left off, I'm going to take you through how we've implemented GIS application on our existing database. So first of all, we've converted our existing data, which, as my colleague Yaqub mentioned, MicroStation, Excel, and the photos. We've converted them to the ArcGIS. And the second is, after we created a map using these data, the second step was to maintain them. So we created a map using all the existing data, and we shared it to certain individuals, and we dictated the permissions and on who's able to edit it and and maintain the database. And also we've managed to create an interactive dashboard which shows us the progress of our tasks. The third thing is updating. So by using GIS, we can remotely update on the phone because the map is available both on offline and online. So the site team was responsible for updating. They'll be managed to access the data at any time and anywhere, and they can update it accordingly. And these updates show automatically on the map, so there's no need for someone else to come after you and update the data. And the fourth is analysis. Once we have these maps and once we have performed all the tasks, we can use these maps to perform certain analysis, which I'll be talking about it later.
So after implementing the ArcGIS, MTT has produced two main maps. The first one is the asset management map, which is used to update the MTT asset list with any new bus or taxi stop, or in case of adding, removing, or locating any item on the existing stop, such as installing of a new bus shelter, relocating of the bus pole, or installing of the taxi pylon. While the second map is the inspection and maintenance map, and it is used during the site inspection to report any damage in our assets in order to repair it and fix it within MTT's KPI. So once these damages are fixed and repaired, they will be directly uploaded and shown on the map.
Adding to what my colleague said, because we have these two maps, we can perform as much as analysis that we require. First is the gap analysis. Since we have all the assets located on the map, we can check which area needs additional asset, additional bus lay-by, a cycle lane, or any kind of other assets. And another thing is we can share also the ridership on each bus stop. Once we have the ridership, we can check like what is the priority analysis, what do we have missing there that we can add to that asset. And another analysis that we can perform is the optimum route for the bus stops. So each maybe annually or even less than that, we actually update our bus routes and based on analysis that we perform. So this analysis can also be performed on GIS using these maps that we have produced. By that, we can achieve our strategic goal, which is, as I've mentioned previously, one is to develop infrastructure, and the second is to increase the efficiency of our operation and services. And that's. And I'd like to conclude our presentation. Sorry that it was very short, but that's it. And thank you for listening to us.
Sorry. Yeah, thank you very much, Ms. Shaima and Mr. Yaqub. Actually, you are right, the presentation was short, but it was really like, focused and it was up to the point. And we have seen that how you are using GIS application for maintaining, updating, and analyzing data for effective and efficient infrastructure management and development. At the same time, how you are managing your asset and how you are inspecting them and maintaining in order to, have a very effective transportation management as far as the land transport is concerned in the kingdom, either for people or either for the goods. So thank you so very much. Have a great day ahead.
Thank you very much.
Now our next speaker is Mr. Ahmed Khairat, and he is a technical sales specialist for AEC. That is, and I have been privileged to, listen to him and attended his session before as well. And he's based in Riyadh, Saudi Arabia, and he's an AEC technical specialist working with Autodesk Middle East. He has more than 18 years of experience in BIM, GIS, and FM industries in various roles like engineering, pre-sales, cloud architecture, and software design and development, where he worked with some of the largest companies, ministries, and municipalities in the region and multiple environmental agencies, and has supported the enterprise adoption of technology for multiple big enterprises. So he's going to highlighting the power of BIM and GIS in AEC industry. So please join me in welcoming Mr. Ahmed. So Mr. Ahmed, please go ahead with your presentation.
Thank you so much. So my name is Ahmed Khairat, and I work for Autodesk. And Autodesk is a leader in the building information modeling industry. And as we have seen in the earlier presentations, BIM and the power of BIM is very useful for infrastructure projects where you can go with roads, transportations, highways projects, railways, airports, seaports, and all kinds of capital projects can be handled by BIM and can be using BIM. And BIM as a platform and as a technology can provide us with many benefits. So the digital model that we create, because the essence of BIM is that we create a digital representation of the project that we are creating or we are monitoring or we are operating. And that digital representation does not only include the 3D aspect or 3D component of the system, but what we can extract out of this 3D component, because project documentation or construction documents, quantification requirements, integration with project management and the scheduling software, coordination and clash detection and 3D visualization are all of the outputs that BIM can provide. And in order for BIM to provide these kind of benefits, it needs not only the information of the project, but information about the space and the environment that it's working inside. And previously, that meant that if we want to have information from GIS systems, we would need to extract and export data using shapefiles, using standard TIFF files for raster imagery. And the moment that we extracted this information, it's now disassociated from the source material, from the original and system database. And whenever there is a change in the source information, it's not reflected in the BIM environment. And whenever there are changes that are proposed by the BIM team and the infrastructure team, they are also not reflected back. You need to do it manually twice. So once in the BIM system, and then you transfer the files back into the GIS, and then it has to be redone once again in the GIS system. And all of that contributes that the ability to design with our understanding in the nature and how we can integrate building information modeling and design information systems and models cannot work seamlessly in order to create the city information model, which is the integration and the aggregation of both environments and systems. And because data is at the center of any capital project, we need to change the way that we do BIM and we do infrastructure integration through the GIS data sources, because information have always been inside very powerful systems that can support point of solutions or small isolated requirements. So for one example, if I'm a designer or I'm a construction professional, I know that I have the information, I have the systems that can help me, and that is embedded in the BIM workflow. But if I need something from the GIS dataset, it's a little bit harder to get this information and exchange this information. On the other side, if I am in the regulation and permitting system, most probably my system is in the GIS side of things. So in order to enhance and streamline how we exchange information, we need to build what we can call the information continuum, a kind of path where information flows freely, either inside the systems that are more associated with GIS systems, master planning and regulations and permitting and asset management, or the systems that are more aligned with BIM workflows and software, like design, build, handover processes. So through the creation of this information continuum, it doesn't matter where the information has originated. It doesn't matter where the information system is running. Is it running
Ahmed, your voice is not coming. I think you are muted. Ahmed?
Yes. Can you get me now?
Yeah. Now it's okay. Okay.
Okay,
Please go ahead.
perfect. Okay. So as you said, it's very useful that we can have this information continuum to exchange informations between the systems. much more easily than what we had the ability before. And that enabled, or that pushed, our joint leadership between Autodesk, as you can see here in the image, Andrew Anagnost, our CEO, and the Esri leadership, Jack Dangermont, working together and announcing in the Autodesk University 2017 that we have now entered a strategic partnership between Autodesk and Esri, and that strategic partnership will make a big difference in how we approach and how we design and provide our systems to our customers. So that right now, as we can see, is the foundation for what we can call a city information model, which is a basis for digital twins, for smart cities, and for many other applications of BIM and GIS, IoT environments, system information coming from reality capture, remote sensing, and many other together. So let's take a look on how our platforms and how our applications have already progressed in the market right now, and how can we work together to consume, manage, and utilize GIS information in BIM systems and utilize BIM information inside GIS systems. So one of the applications that a civil engineer or a transportation engineer can use is actually our Autodesk InfraWorks platform. And with the strategic partnership, we have enabled what we call the Autodesk connector for ArcGIS. Now, information inside the portal for ArcGIS or ArcGIS Online can be accessed natively without the need to open and exchange information. I just need a user and the proper permission for the data sets that I wish to access. And by simply selecting the data, mapping it to which real-world object that the InfraWorks model is representing. And I can see here roads, buildings, points of interest, fire hydrants, land zones, many other objects can be mapped, infrastructure elements, all, as we can see, can be mapped here, and even the properties and attributes of the GIS database can be represented. And as we can see here, this is the collector for ArcGIS, which enables the geodatabase to be updated on site. Here, we are adding information of an asset that is represented inside the GIS system, and with simply updating the geo system and by asking the system to refresh, the data set is now present in the BIM model as well. But it doesn't stop on reading and visualizing the information. If I provide my user with the editing capability from inside the Geo Content Management System, the ArcGIS Online or Portal for ArcGIS, I will be able, whenever I do any kind of a change or update to the BIM model, as we can see here, we are changing water pipes, we are changing the manholes, we are changing different elements, doing visual and spatial adjustment to the location and properties of the data set. And by simply going back to our data source manager, which is how we interact with the GIS data sources, it's very easy that I go right click, save back, and the changes that I'm doing is now reflected into the geodatabase. So by simply providing the proper permission for users through the Autodesk connector for ArcGIS, I can make sure that my infrastructure data can be visualized correctly and can even be edited and contributed back by the BIM system. Here we are seeing that we can also utilize not only the ArcGIS Online, but the on-prem ArcGIS servers or portal for ArcGIS, where we can pull private systems and we can focus on data that is available in our enterprise geodatabases instead of systems that are cloud-powered or cloud-based. And one of the benefits of also using the Autodesk connector for ArcGIS beyond the portal platform is that we also have the ability to consume raster datasets. So whether this is coming from a digital elevation model or digital terrain model, this can be visualized and data on the BIM model can be represented by what we have collected on site using either remote sensing, stereoscopic imagery, photogrammetry capabilities in our organizations, and all can be represented as one representation and one digital model. So it's very easy that we can realize the benefits of GIS inside of the BIM systems and provide all of the information that we have collected, that we have worked so hard to collect and make sure that it's quality assured into the BIM model, so that whenever the infrastructure engineers are working, they have the most recent, most up-to-date, and most accurate information for their disposal, and the outputs that they generate is aligned with what we have collected and what we are managing in our geodatabases and our geospatial data stores. Likewise, to InfraWorks, we have our powerhouse or our Civil 3D, which supports the detailed design and the generation of construction documentation for infrastructure projects and underground utilities projects. And as we can see, the same software, it works in the same way. The interface is a little bit more aligned with how the Civil 3D interface works. And we do have our schema mapping capability. So whenever the information in the geodatabase is a little bit different than how my BIM model is expecting the data to come in, I can map that kind of information. But still, I still have access to this information, and I still have access to all the data, all the capabilities that we have seen. So saving back the changes, refreshing the data whenever it's updated in the geosystem. Whenever I have the ability, I can go back, do the save back to the system. I can see vector and raster data sets all working together. And even if I have a data set that is not available or that is not right now present in the geodatabase, so for example, here we are creating a sewer network or a sanitary sewer network system, and I want to publish that into the ArcGIS system, it's very easy that I go select which parts of the system that I want to expose to the geodatabase. I define its properties and attributes. I define the tags that will be present in the portal. I arrange for which groups and which folders to publish these data sets. And with just one click, it's now ready and available inside the ArcGIS platform. So as we have seen, this is a very powerful capability that we can use and that we can manage, and that can provide the right context for infrastructure engineers and BIM professionals. But what about the GIS professionals? So if you are a GIS professional, starting from the ArcGIS Pro version 2.2, now you have the ability to consume BIM information inside your GIS environment. You just need to start with a local scene dataset inside the ArcGIS Pro, and then you can simply drag and drop a BIM model, either coming from Revit or IFC, and it will act just like any normal GIS datasets. Here we can see data we are collecting. We are working with a model builder. We are seeing the data exposed as a web map in a 3D model. We can see the BIM model having the georeference information right inside the Revit model authoring software. And the integration can recognize that georeference, or if the georeference is incorrect, if it's not going into the right location, the information and the capabilities inside the ArcGIS Pro can support georeferencing this information and georeferencing this BIM data model, and even saving this information beside the BIM model so that it can be reused by other BIM models in the project. So for example, I might have the architectural model, I do the georeferencing, and then I can save that georeference data and push it to the structural model or push it to the other models that I have in the system. So as we can see, data sets coming from BIM can be very useful in adding a dimension of information detail that was not present before in GIS systems. We are seeing the data used here. acting natively into the system, and we can see that we can even select an asset or an element from inside the model, just like we do with GIS datasets. But now we are focusing on data coming from the BIM model. We are even visualizing the tabular data just the same way as we are used in GIS datasets. So managing this information can be quite useful to GIS professionals. But what about data that is coming from infrastructure projects? So we have seen that Civil 3D and InfraWorks can get information from GIS and can push that information back to the GIS professionals. But what if the data is already present in Civil 3D format and I want to consume this information in my model? So in ArcGIS 2.6, we have gained the ability to access not only the civil models, but even the civil models coming from our common data environment or our Autodesk Construction Cloud and BIM 360 common dataset, which is equal to the ArcGIS Online content data management system, but geared towards BIM platforms. So now, instead of downloading the models manually, whenever there is an update, I need to upload that version manually. Now I can see the data in its original format and in its original location. And for civil projects, now I can go inside the BIM model that is coming from Civil 3D, and I can see all of the models, whether this is a gravity model or a gravity network, gravity water pipes, a sewer network, I can see, or a pressure network where I push potable water into the model. All can work together, and I can build all the models that I need to utilize and see what's inside a civil model right from inside my GIS environment. And that didn't stop only on the design authoring software or the GIS professional software. We also collaborated with Esri team to build a cloud-to-cloud integration system that works between our cloud environments, the Autodesk Construction Cloud, and the Esri ArcGIS environment. And this kind of integration is now called the ArcGIS GeoBIM platform. We will see in the next video how it works together to integrate between our cloud environment and provide dashboards and provide executive overview about all the BIM information and as well the GIS information in a single window on this GeoBIM information.
In a typical design project, there are many different disciplines that have to come together and collaborate and ultimately provide the best design for the overall project. In this process, all of the project teams are constantly updating a piece of the project and sharing that information with project team members through design collaboration in Autodesk BIM Collaborate Pro. On a daily basis, project managers and owners can quickly review any issues that have been generated for the project, but this list can grow rapidly and become hard to manage. Introducing ArcGIS GeoBIM from Esri. With BIM and GIS cloud collaboration, the cloud-to-cloud connection between ArcGIS and the Autodesk Construction Cloud. ArcGIS GeoBIM enables task-specific web applications that integrate project information from Autodesk BIM Collaborate Pro with geospatial context. GeoBIM enables teams to organize a single project or multiple projects in one view without reorganizing the data. It gives you a single point of contact to GIS data, design documents, and construction documents while maintaining a dynamic link to that data in the Autodesk Construction Cloud. So, if changes are made to the data, the dynamic link brings you the latest information in the GeoBIM app. In GeoBIM, you not only can automatically link to project information, but you can manually link to new project information as it becomes available. A link can be created and attached to the relevant ArcGIS feature. This allows all project stakeholders to see and review the newly added project data in context. Project managers can view issues that have been created in BIM Collaborate Pro or created directly inside of GeoBIM. Performance review dashboards can be used to better understand the status of all issues of the project. In this unified web-based environment, you can create, review, track, and manage issues on one project as the project manager, or if you're an owner-operator, see all of the issues on all projects you have active in your area.
So as you can see, working between the data from Autodesk and Esri can build a very powerful integrated platform that can integrate data from BIM data sources and from GIS data sources together and can push for a common environment where not only BIM data can be visualized and GIS data can be visualized but they can be integrated together and can be visualized in a connected data environment. So let's take a look about a couple of real-world examples as how we can integrate between BIM data and GIS data together. So one of the projects that have used BIM and GIS integration is Arambol-Sweco intercity project, where data from the BIM and GIS have been integrated together to build what we call a design environment or a design review environment that integrates data not only from the project model and design, but has actually collected information from more than 120 different data sources and enabled these different data sources to work together to make sure that the design approvals are done in time in a much more quicker way than what we normally do in design projects using only 2D data sets and only even BIM data sets. And by doing this BIM and integration capability, we have enabled 20% saving in the time of design review and acquiring the design approvals. So what had been done is that in this project, information that is coming from the municipality, coming from the environmental agency, coming from the city, and coming from the engineering teams have all been connected with the geographical names, political boundaries, environmental information on neighborhood and outdoor recreational areas, cultural heritage environments, and the space, data coming from the natural resources, the waterfront, the areas that might be affected by the project, the endangered species areas, which happen to be near the city and near the project area, landscape and the cityscape model, geological data and how it can affect the project design, the 200 years of flood analysis, all have been collected, aggregated and showed on top of a unified model so that the model of the project itself, the intercity road, can be seen quite easily and quite quickly using the design approval teams and workflows. Another example that we have is the city of Paris. So the city of Paris have been hosting the most visited touristic attraction in the whole world, which is the Eiffel Tower promenade that attracts the largest number of tourists from all over the world each year. And in order to improve on the experience of these tourists and to build and improved image to the city of Paris have worked with a number of consultants and experts in the market to collect and build a complete GeoBIM model that can be used by multiple stakeholders and can be the basis for reimagining how can we improve on top of this model and space. So it started with a complete collection of point cloud information using vehicle devices and laser scanners mounted on top of vehicles. And then these point clouds, in addition to data sources coming from GIS datasets, have been aggregated and federated inside the Autodesk technologies to build very high quality representation of the city, not only the roads, not only the buildings, but even monuments and touristic points of attraction, the promenade area, the fountain area, and even the main attraction of the city, which is the Eiffel Tower itself. So as we can see, we aggregated a huge number of models, and we have incorporated information from a multitude of data sets to not only build on the 3D model, but even continue that kind of integration with gaming engines. So we have utilized a game engine to provide an interactive visualization of the Paris city. And this interactive visualization was actually handed over to 4 different design studios, where each one of them has built on top of the existing conditions model and built their own models that showcases how the city can be upgraded and moving forward in their opinion about the future of the city of Paris and this touristic attraction area. And what's astonishing about this integration and about this collaboration between these different design studios and the city of Paris and the different consultants working for the city is that these different 4 models have been publicly available to the citizens to comment on top of them and provide their feedback, providing citizenship participation and a model to engage the not only the officials and not only the design studios, but all the stakeholders, including the citizens of the city, in order to provide a comprehensive model on what can be done to the city and how they can be affected by these kind of developments. And if you just scan the QR code from the slide, you will be able to go into the application or to go to our website and view and download your own copy of this area and see for yourself how you can experience the city of Paris digital model and digital representation. So in conclusion, if we want to build the complete product environment and common data environments, we need to incorporate not only BIM data sources and GIS data sources, but more importantly, we need to incorporate data from both market leaders in BIM and GIS and make sure that information is flowing freely and easily between the different professionals and stakeholders in order to make sure that we are able to deliver increasingly complex projects in less time, effectively communicate project intent to stakeholders, and reducing risk by making sure that the right information reaches the right people to get the right decision at the right time. And with that, I thank you for your time. I hope that we are on schedule, and it's my pleasure to meet you today. Thank you.
Thank you. Thank you very much, Mr. Ahmed, for sharing your expertise with us. And your presentation was not only informative, but also engaging and thought-provoking. And finally, the integration of BIM and GIS is a powerful tool that you have discussed with us for improving project efficiency.
Yes.
For improving project efficiency, then sustainability and decision making across a wide range of industries, from construction, urban planning to facility management and disaster response. So what was like very interesting there to notice that GIS inform BIM and BIM fuel GIS to born and give birth to CT information model. So thank you so very much for this fantastic session. Now we are proceeding forward, and now the next presentation is going to be from Ms. Aisha Al-Jawdar from National Space Science Agency. And she is going to talk about that how the application of space technologies is empowering agricultural data analysis. And she's a bachelor, she has got bachelor degree in software engineering and working as a space data analyst at NSSA for the past year, where she had the responsibilities of processing satellite imagery and developing projects through the analysis of geospatial data. And of course, she is going to tell us about that how these applications are empowering the agriculture. So, Ms. Aisha, please go forward with your presentation.
Thank you, Doctor, for the introduction. And also like to thank Microcenter for the opportunity to present our work at NSSA during the annual GIS event. So the topic that I will be discussing today is how we have implemented remote sensing and GIS technologies in performing a comprehensive agricultural land assessment for the Kingdom of Bahrain. I'm just going to give a brief introduction to NSSA before I dive into the main topic, in case the audience would like to know further about us. So the National Space Science Agency was established by Royal Decree for the year 2014. The establishment was 2014 when we began actual work as an organization in 2018. And our vision is to take Bahrain to a position ranking with developed countries in space sciences that enables achieving comprehensive and sustainable development. And our mission is to apply integrated initiatives and programs to respond to national requirements and to sponsor and develop space scientific technological activities, research, and concepts for achieving comprehensive and sustainable development. There are 6 strategic goals that the NSSA is operating on for the years 2019 to 2023, and these goals are to be updated for the upcoming year 2024. So these 6 goals are constructing a sound infrastructure for space development, responding to national requirements through providing space information and Earth observation data, encouraging the Kingdom to become a party in international conventions and agreements of space science and associated technological concepts, building national capabilities in space engineering and space science technologies, establishing relationships of cooperation on regional and international joint projects with space agencies and with technical, industrial, and research organizations, and promoting space science through awareness, developing advanced research programs, and enhancing innovations.
Hello, I think the presentation is on the first slide only, or it's available for everyone.
Yeah, the
Can you
application
see
is
the
available
slide?
and it is on first slide. Yeah.
Is it
No,
in the
it's-
slide services?
No.
Okay, give me 1 second, sorry.
No problem. Sure.
Okay, can you see the slide of services or?
Yes, yes, Ms. Aisha. Yeah, please.
Okay.
Go ahead.
Okay, so I was showcasing the strategic goals previously and our vision and mission. So I will be going now to the services. So there are 4 main services that we provide. The first service is satellite images and data. So we provide satellite imagery for the lands and the territorial waters of the Kingdom in different spatial, temporal, and spectral resolutions. The second service is processing satellite imagery and data. So we perform the necessary processing procedures for the satellite imagery to provide accurate and enhanced data to the requested clients. The third service is producing analytical studies. So we perform different geospatial and data analytical studies utilizing our satellite imagery, which in turn results in the creation of a geodatabase with the needed information for the relevant entities to conduct decision-making procedures The process for our analytical studies are either specific requests from entities in which there is a discussion on the implementation, or initiatives from our data analysis laboratory to support national geoinformation. Lastly, which is training and technical support. This service is usually offered with the third service, analytical studies, and this is where we provide support in the utilization and comprehension of the studies conducted, as well as workshops and trainings for entities in regards to space technologies. So now I'll be moving on to the main topic of discussion, which is the agricultural land assessment. What is meant by this is an analysis of different components, which we will see later, that affect the growth of agriculture in the Kingdom of Bahrain. So there are 4 main goals in implementing this assessment. The first goal is to establish an Earth observation sector in the Kingdom of Bahrain. So as the entity that is responsible for the space sector, it is of significance to continuously enhance and build national capabilities in implementing space technology such as remote sensing and satellite imagery. So these satellite images are processed and analyzed in order to extract different types of information that can serve a very wide range of applications and industries. So continued development of this path, we have conducted this assessment to benefit the agriculture sector. This then leads us to the second goal, which is to fuel geospatial and agriculture information. So the qualities of Earth observation enable us to have access to agriculture information in a more robust, fast, and inclusive manner, where we can cover the land analysis of larger areas and at different time periods, while maintaining time efficiency and reducing time-related costs. Then this information can be used for a very wide variety of purposes throughout the vegetation growth phase. So before implanting the plants, it can be used for analyzing and developing estimates for crop area and yield. It can improve the financial planning, also the distribution strategies, and creates a more efficient allocation of resources. And when it comes to post-harvesting, it can be used to assess the growth, which also minimizes the cost of actually visiting the plot. Then this agriculture information can facilitate the measurements of the achievement of the net zero goal set in COP26, which is to cut greenhouse gas emissions to as close as zero as possible, while any other emissions should be reabsorbed by the atmosphere. So in order to achieve this, in terms of agriculture, the Kingdom has set plans to double the tree coverage and quadruple the mangrove coverage. So in this assessment, it will assist in identifying the most suitable land for crop growth according to various factors, as well as it will measure the changes in these factors as the overall green coverage of the Kingdom increases. All of these goals then pool into one essential aim, which is to support our stakeholders and the relevant decision makers from various entities. So it allows them to utilize this information to monitor trends and patterns and quickly address issues, which aids in realizing long-term goals of sustainable development. So there are 6 steps that are involved in the methodology of assessment. The first is research and requirement gathering. So we conducted research to see what would be the most suitable and feasible characteristics that can be considered to perform the agricultural land assessment. We considered the availability of data, the characteristics of the Kingdom, and applying specific remote sensing indicators, as well as the relevancy of these characteristics in accordance with each other. Another thing we considered is the specific needs of our stakeholders to implement them in the assessment. We then conducted multiple testing for various implementations of the characteristics. And based on this, we reached 5 main components or characteristics that we studied, which I'll be showing in the next slide. The next step is satellite imagery and data collection. So after conducting the research, we started preparing the necessary satellite imagery for the time period that we're going to conduct the study on. So the study was conducted for the summer season. So we prepared satellite imagery for June, July, and August in order to perform the pre-processing steps. We also prepared other needed data in the form of shapefiles in order to perform our analysis. This leads us to the third step, which is the pre-processing. So this includes cleaning and prepping the data, correcting instrument errors, removing noises, converting data into a standard format, and all other raster processing such as mosaicing, or projecting clipping in order to prepare the imagery for remote sensing processing. This leads us to data processing. So this is where we implement various remote sensing indicators for all the months mentioned, and through this step, we utilize the different spectral bands of the imagery and calculate specific band statistics. The results of processing each agriculture characteristics for each month is then averaged according to the month and is utilized to present the summer season, which is then considered for analysis. The data analysis step is where we use statistical techniques to extract meaningful insights from our data. So we analyze the data by classifying the remote sensing results and to compare these results according to different spatial features and to each other. And the last step is data visualization. So based on the results of the data analysis, the appropriate visualization in the form of maps, charts, and reports is presented as the final output of the assessment. In this slide, you can see the 5 characteristics or studies that we have conducted and aggregated as a part of our agricultural land assessment. The assessment, as I have stated previously, has been done for the summer season of 2023. And the 5 main components explored are chlorophyll content, leaf water content, soil moisture, soil salinity, and land surface temperature. In the following slides, I'm going to go further in depth for each of these components. So the first study is chlorophyll content. So chlorophyll content is important to measure vegetation production. So measuring chlorophyll content allows us to monitor the vegetation health and the plant strengths. This is because chlorophyll is a pigment that gives vegetation their green characteristics, and most importantly, this pigment is relied on to absorb sunlight and it converts to sugar and starches in photosynthesis. So a low chlorophyll level would indicate a limited ability to photosynthesize, thus the plant would possess lower production rates. And by this, we can effectively analyze the vegetation health. And measuring chlorophyll can be a more precise way to identify vegetation health than the traditional NDVI, as NDVI focuses on the biomass density, which does not necessarily indicate to the health of vegetation. So through remote sensing, we're able to extract the spectral reflectance of chlorophyll. To do this, the analysis utilizes the narrow spectral band that's between the red and the near infrared band, which is the red edge spectral band. So the red edge band is very sensitive to the light that's reflected off the cellular structure of the plants, and it shows the variation of the chlorophyll content. So the brighter the reflectance, the larger number of plant cells, and the greener the area, which means the more chlorophyll it possesses. As it can be seen from the chart, the chlorophyll content in the Kingdom of Bahrain is generally low, with 81% of the area classified as low, and only 16% as moderate, and 3% as high. And you can see from the map visualized on the right, the location of the classifications of chlorophyll content on the Kingdom of Bahrain. Second study is leaf water content. So leaf water content is one of the main biophysical parameters to discover the health of vegetation in terms of water availability. So it's an indicator of essential processes for plants, such as photosynthesis, transpiration, and respiration. So areas that have generally moderate or high water content are regarded as well-watered areas and vice versa. However, this interpretation of the suitability of water content is dependent on the type of vegetation that's in the area. In addition to this, climate change, which has been increasing rapidly, has induced water scarcity in many parts of the world, which leads plants to live under extreme situations of water stress. And this caused a reduction in crop yield. Especially in the Kingdom of Bahrain, we are considered as a desert island. So in order to understand this, we have studied the leaf water content in the kingdom. Spectral reflectance for leaf water content is represented in the near-infrared and short-wave infrared bands. So these bands aid in the detection of vegetation water content because the near-infrared band detects the bright reflectance from the leaf internal structure and dry matter content, while the short-wave infrared band is sensitive to the leaf's mesophyll structure. And when these both are utilized in specific calculations and modeling, we can obtain an estimate of leaf water content. As you can see from the chart, the results are very similar to chlorophyll content, almost 90% of the kingdom possesses low leaf water content, and only 9% as moderate and 1% as high. And if you notice, when I switch between the chlorophyll content and leaf water content, areas that have lower leaf water content are also areas that have lower chlorophyll content, and vice versa. On to the third study, which is soil moisture. So soil moisture is considered a key hydrological component for a lot of earth and environmental applications that impact the global environment and human society. So the identification of soil moisture can aid in a lot of applications, such as prediction and monitoring of drought, managing and allocating water resources, agriculture, plant production, and a lot of other applications. So because of this importance and the wide range of applications that is needed from highly available spatial and temporal soil moisture information, we have decided to implement this study. So when we talk about soil moisture, it represents the water that resides in the pores of the soil. And the level of soil moisture is determined by a lot of factors, such as weather conditions, rainfall, temperature, as well as the soil type and the associated vegetation. In turn, this soil moisture also affects a range of soil and plant dynamics. So the model definition for soil moisture considers four main aspects. The first is the current soil moisture, which is the actual moisture at the moment of measurement. The permanent wilting point, which is the second aspect. This is the point in moisture level where the plant root system cannot withdraw water from the soil. The field capacity, which is the maximum amount of water that the soil can hold. And lastly, the residual soil moisture, which is the minimum moisture level that the soil retains. So all of these four factors are modeled as well in specific calculations that enables the detection of soil moisture. As you can see from the chart, we have almost 77% of our land that has low soil moisture during the summer season of 2023, around 20% as moderate, and 3% as high. And you can see as well in the visualization of the map, the locations of the different classifications of soil moisture. The fourth study is soil salinity. So soil salinity is a measure of the minerals and salts that can be dissolved in water. So soils that are affected by salt are either a result of the excess accumulation of salts that have built up to the surface of the soil as a result of evaporation, or they can also be concentrated in soils due to human activity. For example, the use of certain fertilizers can cause naturally occurring salts in the soil. And soil salinity is an issue that's expected to impact the world more extensively in upcoming years. This increase in the soil salinization can also be attributed to increase of salinity in water resources. So this soil salinization, it will change fertile land to unproductive land, and it's considered one of the most severe factors that affect the growth of plants. So as the soil salinity increases, it can cause degradation of soils and vegetation. So due to these negative impacts of the salinization of soil on the fertility and agriculture production, there should be a lot of attention dedicated to finding ways to preserve soil quality and reclaim saline soils. And a first step in assessing this soil salinity is to assess the spatial extent and the severity of soil salinity in the areas of the kingdom. So to conduct this, the spectral bands of the shortwave infrared have been utilized. And a lot of different studies have demonstrated that the shortwave infrared bands are more sensitive than other bandwidths to categorize soil salinity, especially in irrigated agricultural lands. It is more sensitive to changes in soil salt concentration, and it can be applied to a wider range of soil types. And the modeling calculation for soil salinity is based on the thermal properties of the soil. So saline soils have a higher thermal inertia than non-saline soils. This basically means that they take longer to heat up and cool down. As a result, the saline soils will have a lower temperature contrast between the different spectral bands. And through this, the analysis was conducted. So you can see from the charts, almost 80% of the land has high soil salinity, 70% is moderate, and only 3% is low. However, if you compare soil salinity with soil moisture, you can see that there is a negative correlation between the two, where areas with very high soil salinity also have very low soil moisture, and areas with very high soil moisture have low soil salinity. And this is proven because the irrigation of soil does decrease the concentration of soil salinity. So the final study is land surface temperature. So temperature is considered one of the three major influences on vegetation growth, alongside with sunlight and water, which we have explored in the other studies through chlorophyll, leaf water content, and soil moisture. So the temperature determines whether the land can support dense forests, grassland, or it can only support barren desert. It can also determine the type of land, since the presence of vegetation does impact the temperature. So in areas where vegetation is dense, as you can see from the map here, the areas with vegetation, the land surface temperature will be lower, and areas with high urban density or areas of industry will have the hottest land surface temperature. So how do we measure land surface temperature? It's a measure of the thermal radiance from the land surface, which is how the incoming solar energy interacts and heats the ground or the surface of the vegetation. And it's an important factor related to surface energy and water balance at both local and global scales. Land surface temperature can also assist us in identifying specific aspects related to temperature that are important, such as the spatial distribution of temperature patterns, identifying areas with anomalous heating or cooling, assessing the impact of environmental factors on land surface temperature. So from the chart, you can see that 66%, around 60% of the land has high land surface temperature, around 25% is moderate, and around 9% is low. So to enhance the analysis further and to provide more context to the results of our analysis that we have done for the 5 studies, we have performed 3 additional types of analysis. So the first is the analysis that is based on the areas in the kingdom, where the average of the area is calculated for all 5 components. This way, we're able to extract how the values differ between one town and another, and how these values relate between the 5 different analytical studies. Then we further generalized it by analyzing based on governorates. This allows us to view the results of the study on a higher level of abstraction, and it creates a simple analysis based on larger areas. This could be used to generally monitor the changes or progress between different governorates. We also have performed a comparative analysis, which puts the 5 analytical studies to further good use by plotting them against each other to detect any patterns or correlations between the components. For example, as I have mentioned earlier, we have discovered that areas with low soil moisture had high salinity and vice versa, and areas with low chlorophyll also had low leaf water content. Thus, through this, we were able to extract more meaningful insights from our analysis, and through this, the decision makers can clearly identify the areas that could be more suitable for agriculture, as well as the areas that require more attention in terms of irrigation or other relevant agriculture and maintenance. So this agricultural land assessment is a study that our satellite imagery and data analysis laboratory has performed for the first time this year for the summer season. Therefore, we have set plans to develop this project further and to continue in the development in the field of remote sensing. Initially, we have plans to implement this study for the winter season of this year as well. This will enable us to conduct more meaningful comparisons for all 5 studies between different seasons, and it will provide us with information on how to manage agricultural lands in the kingdom based on seasonal changes. We're also in the process of identifying further factors that we can detect alongside the 5 other studies that we have implemented. This is, of course, to add an additional factor of examination and to provide further useful information in terms of agriculture. Another aspect we are seeking to conduct is integrating our data with in situ measurements through ground truthing. So this will enable us to compare remote sensing data with field measurements and shall guide us in the implementation of the assessment for future years and for different seasons. The last point is to utilize the results of the assessment in measuring the impact of the national agriculture initiatives on these 5 studies. For example, we can view the impact of increasing the green coverage on the land surface temperature and chlorophyll levels by creating a time series analysis of the data. When it comes to conducting remote sensing and GIS analysis in the agricultural sector, we supply our data on a regular basis to the National Initiative for Agricultural Development, where it is hosted in the respective portal agro.bh. Currently, you can find the results of our previous studies such as green areas, greenhouses distribution, palm tree distribution, and mangrove distribution in their portal, and these studies are also updated on a routinely basis. And also, the current agricultural land assessment study that we have conducted for the summer season is provided to NIAD as one of our major stakeholders in the field of agriculture. The topic from our presentation for our GIS Day today has been discussing mostly the studies we have done for the agricultural sector. However, as I have stated in the initial assessment goals, we place high importance in utilizing Earth observation capabilities from multiple sectors. For example, we have conducted studies in urban planning and infrastructure, such as land cover, land use classification, urban change detection in reclaimed lands, and violations detection in industrial areas. We have also performed projects in disaster management, such as the impact of sea level rise, oil spill and ship detection, as well as an AI-powered dust storm movement prediction. And by this, I have reached the end of my presentation today. I would like to thank you all for attending, and I hope you enjoyed viewing the integration of remote sensing, GIS, and agriculture. If any one of the attendees has any questions or would like to know further about the agricultural land assessment or any of the projects that we have done, please feel free to connect to us to the email displayed on your screen currently, which is nssa@nssa.gov.bh, and we'll get back to you. Thank you once again, and back to you, Doctor.
Thank you very much, Ms. Aisha, for seriously very excellent presentation. And your depth of knowledge and attention to detail were really, evident throughout your presentation, and especially the application of space technologies in terms of analyzing the agricultural condition. Like you talk about the soil mechanics, you talk about the chlorophyll and other analysis when it comes to this. And at the end, when you discussed that how we can utilize these technologies in order to have food security and maybe sustainable agriculture and forestry, maybe it can extend it to maritime, inland, or even to water research with the help of AI and all that kind of disruptive technologies which are coming in this particular area when it comes to agriculture. And also, I think someone is having one question for you. So would you like to answer that question now, or we can send it? Ms. Sheikha May is there with a question. So Aisha, would you like to take this question?
Yes, of course.
Yeah.
You may ask your question.
Yeah, please, Sheikh.
I'd just like to thank Ms. Aisha for the presentation. It was by mistake. I wanted to just applause.
Yeah, okay, ma'am.
Thank you very much.
Thank you so very much.
Wonderful presentation. Thank you.
Thank you very much. And lastly, when we talk about the, your collaboration with NIAD and the e-government when it comes to Bahrain.gov. So it was altogether fantastic. So thank you so very much. And we wish you all the best in all your future endeavor to make, this space technology more and more beneficial for agriculture sector in the Kingdom of Bahrain, for the people and our, guys who are into this sector. Thank you so very much, Aisha.
Thank you. Thank you.
Now we are going for the next presentation, and that is from a group of great speakers from Ministry of Works and Construction Project Directorate. And I have with us today Mr. Zuhairi Ahmed. He's a senior project architect. Mr. Syed Hussain, he is an architect, and Mr. Muhammad Al-Sihali, he is a BIM manager. And they are the architect for the Ministry of Works who contributed to the first BIM pilot project for the ministry, and they are attached under the educational facilities design section with a focus on designing public school in the Kingdom of Bahrain. And they are going to talk about their BIM pilot project. And seriously, we are very excited to see that, how we have started this project in the Kingdom of Bahrain that can be translated later into the application. So the group, now it's your time. So please go ahead with your presentation. All the very best.
Very much. I hope everyone can hear me. Just raise your hand if you can hear me, just to.
Yeah. It's fine, sir.
Okay.
Go ahead.
Excellent. Okay, so good morning, everyone, and thank you for attending. My name is Mohammed Lishali. I am the BIM manager for this project. Joining me are Mr. Zahiri Ahmed, the senior architect, and Mr. Saeed Hussein, the assisting architect. We represent the Construction Projects Directorate, and we're responsible for all public sector building projects in Bahrain. This presentation will introduce the pilot project team. We'll explain the prerequisites that led up to this project and discuss our journey. I'll start explaining briefly, followed by Mr. Zahiri, who will go deeper into the design process, the site considerations, and the creation of the BIM output. This will include a 10-minute live demonstration by Mr. Sayed, so that you have an idea of what the slides actually mean. So whatever we're showing you in terms of slides, we'll also show you as a demonstration. Finally, we conclude with a Q&A session. I do ask that questions focus more on our roles as architects. We do thankfully have some of the structural engineering team and some of the mechanical and electrical team here as well. But whatever questions we can't ask, we have no issues with responding to emails. The team comprised us three, of course, and a senior architecture technician, along with one engineer and one technician from each engineering discipline. In the beginning, most of whom had no knowledge of BIM or Revit, except for myself and a little bit for Mr. Sayed. And this is the journey of this team and the wonderful achievements that I'm so proud to have been a part of. I'll pass this now to Mr. Zahiri to discuss the Wadi Al Sail pilot project. Mr. Zahiri? I think you need to unmute Mr. Zahiri.
Assalamu alaikum and good morning. I hope everyone can hear me.
Yeah.
Yes, we can.
Okay, right. So as you can see, this is our first BIM pilot project known as the Primary Intermediate Girls School at Wadi Al Sail. As you can see here, actually what you are looking is at the actual Revit model or the actual BIM project, which involve multiple complex blocks, each with a unique function and scale, along with smaller buildings for services like guardhouse and the substation and stuff and that, and also some sport facilities. So our modeling strategy for this multi-block layout was very critical. As you can see here, for those who are familiar with the location, the project is located near Wadi Al Sail Mall. So for those who stay that area, this is the location indicated in red there. As shown in this site plan, the sequence for modeling was very critical because you can see that there's so many blocks there. As we started with the most complicated building, which is the one on the mark number 1 there, which is the admin block, and then slowly design the rest around the site. The Revit models that we have done include one administration building. Then we modeled the 2 academics blocks. Actually, one model, but because of a typical block, then we kind of mirror them. But it's actually we have to do 2 models of the same design. So we have academic for primary and also academic for intermediate. Then we have to do a model for the guard room, one for the pump room, and one for the substation. Our modeling flow began with the administration building, followed by the academic blocks, and then the guard room, substation, and pump room. This is an iterative process with constant modeling. So meaning that you are going back and forth between this model, changes, and doing a lot of improvements, and reflecting the dynamic nature of the design flow. If you could, it's not one single building. We are talking about going back and forth with so many buildings at the same time. So then this led to the consolidated site model. As you can see here, this one is actually the actual Revit model, and in fact, the background is the actual site. You can still see the topographic line there. So this is the actual models on the site in Wadi Sil, right? So this is actually the consolidated site, the what you call consolidated model. Mr. Site later will demonstrate how these models requires transitioning from a singular building model to a collaborative multidisciplinary approach. This collaboration results in a single source of truth for the project. So basically, you can see here, basically the architect will do the architectural model, and then the structure will do their scope of structural model. Mechanical will do their own mechanical model, and then the electrical team will do their electrical model, and we consolidated them into one single model. So Mr. Said will demonstrate this in the live demonstration later on. So one of the important element in doing the Revit model is integration of small items known as the 3D objects. These 3D objects with embedded data applicable across the discipline. For example, like in architecture, they can represent doors or windows, and in mechanical engineering, they might represent like AC units or plumbing fixtures, and for electrical, could be light fittings and DB and stuff like that. So in order for you to start the model or the project, you must have all these 3D models prepared earlier. All right, so it's just for better workflow. Here is the one example of a door family where you can see actually we use parametric design to adapt different doors to our design requirement. So this particular family of a door family, you can adjust everything about it. You can adjust the width, you can adjust the height, the material, everything related to this particular family, you can adjust them, right? So that is the beauty of this BIM modeling system, that you can adjust things and it will be reflected everywhere in the model. So design automation is one of the main things, as you can see in the slide. Design automation can also be enhanced through using families. Using family ensure that all the drawings, whether elevation, schedule, or 3D views or floor plans, are coordinated from a single source. So meaning that, sorry, there's a call coming. Okay. So that all the drawing, whether you are working on the elevation or you're working on the 3D model, scheduling, or the door, so any changes to any particular family or any particular element will be reflected in all of the other views or element, right? So in this example, in this slide, I'm showing you, for instance, if I want to change this aluminum door, AD1 as it is known, that all other part of the representation, like in the elevation, it will automatically change. So in 3D also, it will be automatically changed. And the next beauty thing is that even in the schedule, it will automatically change. You change the width of the door from 1.5 to 1.8, then you don't have to go back to the schedule to change it. It will be automatically changed, right? So that's the beauty of, because you are talking about single source of information. You change one place, everywhere else will be changed together, right? So design automation can also be enhanced through scripting. This actually, what happened is that we were thinking at one point that you want to do a design with a single click, right? You want to do a design with a single click. So this enhancement through scripting, which will be shown by Mr. Said later on, will discuss a simple script that we can create for automatically selecting specific finishes for the floor in the different rooms, meaning that with a single click, you can actually do a floor finishes for all the rooms. That's another advanced things about these BIM processes. So this is the this script application within a model will as demonstrated here, showcasing the selection of porcelain tile for the floors, and then specifying the level and room for script application, meaning that you can just select wherever you want to do the tiles or the floor finishes, just select the material, select the floor with a single click, which is the blue run there. With a single click, you get it done, I mean, quite very instantaneously. So that's the beauty of this, right? An additional benefit for this workflow is a clash detection and coordination. In Revit, we can use what it is called a copy monitor, where it features to track changes across discipline. And also it communicates issues using built-in function as shown in this example, meaning that because in a building we have multidisciplinary people working on their own model, but when we consolidate the model, so any changes by others will be reflected in this so-called copy monitor. And you can see that also in this example, you can see that somehow the firefighting pipe is showing in the car park. So we need to say the plumbing pipe is showing in the car park. So we need to lower down, right? So this is the design decision that we have to make. So there's another in this slide. There's another software which is very important in this BIM implementation. It is known as Navisworks, which it assists in identifying clashes between disciplines using a very sophisticated algorithm, right? So here are the example. This process actually can generate detailed report, as you can see on the left, and also as illustrated here, enabling us to monitor clashes on daily or weekly basis. Depends on how critical some issues is that you have to do this clash detection, so that you can minimize all the issues later on during construction. So these are some of the example of those clashes, very detailed. You can adjust to whatever things you require. Sometimes need major adjustment, sometimes you can just ignore. This one is a design decision end of the day. Now, one key advantage of our design is that the design team is able to demonstrate exactly the material, the texture, and design intent to the client, and also for our own study. So Revit allow us for this through both in drawings and also 3D renderings. So it go beyond what we used to do in CAD, right? In CAD, in 2D, you cannot see this. But now with BIM, you can actually see the material. Like in this case, you can see the pavement and stuff like that, right? The pavement, the plaster, the paint, everything. You can see, you can present them to the client. And these are just a few rendered image of the project. You can see the admin block in the front and the 2 academic blocks at the back, and another view of the rendered image from the model. This is the student plaza, and then another view to the student plaza. And then this is the view from the academic block within the 2 academic block with the fabric canopy, just a design elements. And currently, as we are in the ministry, we are still producing drawings for our construction purposes. Of course, in future, things are getting improved. At one point, we may not need the drawings, to be honest, because everything is doing in through the system already. Everyone is having their own 3D software that can read the drawing. But at the moment, as in the ministry standard, we are producing drawing that not only automate processes, but also adhere to the established standard of the Ministry of Works. Here is the example of the documentation. Here is the example of the site plan documentation. And here is the example of our floor plan documentation. And now I will hand over to Mr. Said for the live demonstration of the followings, right? And the floor is your side. You can say, you can share your screen.
Thank you, Mr. Zahir. Can everyone see my screen?
Yes, we can see your screen.
Yeah. Thank you, sir. So now I'm gonna give you a walkthrough through the Revit model and how we produce all the drawings and the different views and the different work that the different disciplines worked on. For example, you can see here, as my colleague Mr. Zuhairi previously mentioned, the admin block with all the different disciplines where you can see all different elements in one source of truth. And if I segregate those information, I created view templates where everything is segregated. For example, here you have the structural elements where the structural team worked on. And here you have the mechanical parts where you have all the ducting, all the pipes and the connections. And as well, here you have the electrical parts where you have all the lighting, the different sockets, and so on. And another part that I will be discussing about is Dynamo, as my colleague previously mentioned. So if you go to Dynamo, I'm going to show you the script and this is the environment of Dynamo. And here you create the script that you want in one click to do a function that you want. For example, this script will demonstrate creating floors to all the rooms that you have. So if we go now we go to the model and we go to Dynamo Player, a window like this will come up and you will have the script that you created already loaded here. And then you use the script to produce what you want. So to show first, yeah, you run the script, you choose the type of floor. You, for example, will choose porcelain tiles. Then you choose the level, for example, ground floor, and then you select in Revit the rooms that you want. For example, you select the rooms, you finish, and then you run it. And it will be completed. And then you will see here all the rooms already created for the floors. See the person file? This is a section view of it where everything been already created just with one click. So that's the benefit of Dynamo, speeding your process of working. And now I'm gonna go to demonstrate the one type of family, which is the door that my colleague Mr. Zuhairi mentioned. And I'm gonna just show how parametric it is by, for example, just changing the width and the height of the door. Okay. For example, the height, we'll change it to 3 meters, and let's change the width to 2.5. And when you press apply, you see the door automatically changed to the size that you required. And if you go back, see how it flexes basically to the shape and size that you want. And the same concept goes to the window as well. And some of the benefits as well of using Revit and BIM is the ability to isolate and to show what you want at any point of time. For example, you can show the whole building. If you want to isolate just the windows, or for example, filter, you go to, let's say, just walls, for example, and then you isolate. And you isolate the elements, and it just shows the elements that you want. And that can apply to anything from windows, from doors, from small parts, so you can do whatever you want and show whatever you want to the client. And with one click, you bring back everything that you want. So this is just a brief demonstration of the abilities that the software Revit and BIM, the way we implemented it all in one source. And now I'll leave the floor to my colleague, Mr. Mohammed, to wrap up about the difficulties and the lesson learned from this pilot project. Mr. Mohammed, the floor is yours.
Thank you. So just to quickly touch on the lessons learned, I want to give as much time for everyone to ask any questions they have. Number one, team alignment. So it was very crucial that every team member understands the true definition of BIM and the difference between BIM and Revit. In terms of the keys to our success, this is number one, because we believe that this kind of understanding is rare in the industry today, because so many people conflate the two, right, between the tool and the process. We also recognize the importance of adapting. So we had a long adaptation period. Transitioning to BIM is not instantaneous. It takes time, it takes patience. So adjusting to this is a gradual process. We also found that targeted training was much more useful than general training. This allowed us to tailor the needs to the project member and the team member and give them the knowledge they need, because every employee is coming from a different background and with different experience, and it's important to cater to where each employee is and make a cohesive team. Another advantage for us, at least, was standardization. This allowed us to have a clear set of protocols. So this was done in parallel with the training. So once the employee is done with the training, then comes the standardization. And so they're going from learning the tool and learning the process to now learning the Ministry of Works process and how the Ministry of Works has chosen to apply this. This was done in parallel by the management team to make sure that there is a standard document called the BIM Standards Manual. And we gave it to all employees, and we gave them training on this manual to make sure that we all have a clear set of protocols to follow. So this reduces confusion. Everyone understands that we're on the same page. And this reduces confusion and increases quality. And in terms of model checking as well, we're trying to keep the model healthy. So we do regular checks on that. That's during the project. That was also critical to our success. And it showed basically all of the issues that we were running into regularly. Another very significant thing was early clash detection. This for us was an eye-opener. Identifying clashes early in the process allowed us to coordinate in a very effective and clear way, in a way that 2D could have never given us so early. So in conclusion, just to pass it to everyone to start asking questions, these lessons that you see here and many others have been instrumental for this success of the pilot project, but it's also shaping how we see things moving forward, and we're constantly adapting. Yes, it's important that we gave our employees an education. Yes, it's important that we gave our employees the software and the processes and the tool. But it's important not to focus on all of those, because those are just enabling people to do what they can already do. BIM doesn't change what you do, it enhances it. But it's important for you to pick out how it enhances it, because for us, priority number one was how to conform to the Ministry of Work's strict requirements, and then build and innovate on top of that. Yeah, so thank you for your attention, and we welcome any questions you have.
Thank you, Mr. Zuhairi and team. If anyone is having any question, they can ask, or you can write to us also. I think your presentation was so well made. So I think there is no question that any of the audience is having at the moment. And this is a great example of the probable adoption of BIM technologies when it comes to the Kingdom of Bahrain. And you've shown very well that how we are going to optimize the design in terms of cost, in terms of error-free estimation and overall budgeting of any construction project. So we hope that this project is going to be a landmark for the rest of the sector. Even in private sector, they are going to take it as a benchmark, and they are going to start adopting BIM technology for the projects in the future. So thank you so very much, the team from Ministry of Works Project Directorate team. Thank you very much.
Thank you. You're welcome.
Thank you.
Thank you.
Yeah, now our next presentation is from Esri, and our speaker is Pauline Okio. He is a senior solution engineer. Yeah, she's a senior solution engineer in Esri Middle East and Africa regional team, Dubai. And she is a senior solution engineer with Esri in the Middle East and Africa region, where she supports Esri users in the application of GIS solutions in meeting their business needs. Prior to joining Esri, Pauline worked for Esri Eastern Africa as the professional services manager, managing the training and services portfolio across 5 countries. And before that, in biodiversity management for the Kenya government. She is going to speak upon ArcGIS Pro migrating from ArcMap, and that is the talk of the town. So thank you very much, ma'am, to be here with us. So we look forward for this interesting presentation. So the floor is all yours, ma'am.
Okay, thank you. Could you please confirm if you could see my screen and if you can hear me clearly?
Yes, we can see your screen and hear.
Okay.
Yes, we can see.
Thank you so much. So I'll take the next few minutes to walk through ArcGIS Pro and definitely making a case for why it's important to make that migration from ArcMap towards ArcGIS Pro. So the presentation will just be divided into these sections, trying to understand the reason, fundamentals, how to go about doing the migration, what you can do with Pro, and resources that will help you to start off. Before I get into the migration bit, just to help everyone be at least at par with the understanding of ArcGIS Pro. So previously we've had a powerful tool, ArcGIS Desktop, that's been used, but now for a number of years now, we have had ArcGIS Pro that has been introduced as the latest professional desktop application that can be used to work with your geospatial data. So this is very important because a lot of the modern capabilities towards working with spatial data have been enabled on ArcGIS Pro. So just trying to understand the reason to go to Pro and what are some of the things that are making it a powerful tool. We'll start with the bit that this is multi-threaded 64-bit, meaning that it is now quite powerful and has additional capabilities that facilitate analysis of larger amounts of data, making your interaction and working with data quite responsive. Also, because of these additional capabilities, it is now more efficient to work with your workflows when it comes to trying to visualize your data, editing your data, and so on. And also when it comes to analysis, through these capabilities, we can now derive more accurate results. The second bit is that we have a contextual user interface, meaning that we have menus and we have tools that have been organized based on what you're interested in doing. So we have a top ribbon, and from that ribbon, we have organized tabs that allow you to easily access tools that will be used in analyzing your data, in trying to edit your data, sharing it out, and so on. So these have been organized, again, based on the data set you're working with and what you'd like to do with it. The additional bit is that we can now work with multiple maps and layouts. In order to help you better organize and reach your data and so on, maps and layouts are now put together within a project. So from the project, anything tied to what you're trying to achieve, be it working on a particular area of focus or working on a specific theme and so on, you're able to organize everything that you need within that one project. So from the one project, you'll have multiple maps that allow you to meet this particular goal, and layouts in case you want to create outputs for print. The 2D and 3D experience has also been combined onto one application, hence reducing any clutter that might have been whereby you would have needed previously to exit one application and open another one to be able to get these insights at the same time. So with ArcGIS Pro, we have this one application that has these capabilities whereby you can do your analysis, do your confirmation from one screen. As ArcGIS is a system that integrates the work that you're doing as professionals with other work across the organization, we've also brought in the ability to integrate quite well across the system. So this means that from any desktop workflows you might have, any kind of analysis or work you're doing within ArcGIS Pro, you'll be able to enrich the work that you're doing using data that's within your organization, that's accessible from the rest of the system, be it on the cloud or any other location. You're able to bring this in, you're able to and also enrich your work with other data available from the ArcGIS Living Atlas of the World, which is the foremost collection of geographic information globally, as well as any other relevant or formal source of information you need. So this kind of integration allows you to bring in data from other sources seamlessly, and also push your insights out, that is by publishing information once you're done with your work. So this integration is more seamless and it's quite well integrated within ArcGIS Pro. Also, a lot of the new enhancements or features are being brought into ArcGIS Pro, whereby we have our teams, our product teams that are always working tirelessly to make sure that any new capabilities, any ways that would make it easier for you to work with spatial data is enabled. So this means that all of our focus will be moving towards putting in new features and enhancements within ArcGIS Pro, because ArcGIS Pro is replacing ArcMap. So ArcMap has been there for a while, and right now, the most recent version is being supported until March 1st, 2026, with no plans to make any releases beyond the current version. So we have existing applications or products that are within this side of ArcGIS Desktop that you'll continue to maintain, but we're also maintaining it for quite some good time to allow you to easily transition into ArcGIS Pro and start taking advantage of those new capabilities. So now we'll look at the fundamentals of Pro. Let's start with terminology. As ArcMap users, you're definitely used to some of the ways that you will be able to access your data, be able to visualize your information, be able to do different kinds of analysis and so on. And those capabilities are still there. It's only that we've changed, because of the new interface we have, we've also changed how we were referring to some of these things. We have a terminology guide, which will be shared, which you can refer to whenever you're trying to see or to understand how a previous capability within ArcMap is enabled or referred to within ArcGIS Pro. So when you launch ArcGIS Pro, you will get this tab, which is just introducing you to the Pro experience itself. So from there, you're able to create a new project using any of the templates provided or without a template. You can open a recent project in case you've used Pro before. You can open a project from any other location. And you can also be able to access learning resources that we have. Because we consider a lot of our users may still be trying to find their footing within trying to understand how to use Pro, we've made it easier for you to access the learning resources that we have available. So through our documentation site, we have a number of tutorials that you can use just to quickly get an understanding of how do you create a project or how do you start off in Pro. But we've also linked to other tutorials that we have within our documentation site, ArcGIS blogs, which might have insights such as what's new or what new capabilities are within Pro, as well as links to Esri training. Beyond that, you'll see that for those who are coming from ArcMap directly, you might want specific resources, and we have provided direct linkages towards that. So within the user interface, this is a very new experience that allows you to be able to do the different things that I've mentioned, whereby you can have more a more integrated feel and use of the system, of the application. So starting with the first or the top bit, we have the contextual ribbon, which organizes tools or capabilities based on the data you're working with and what you're interested in doing. Next, we have the excuse me, we have the views. And for the views, this is where we have our maps that you can use to interact with your data. So we have 2D maps that you could use, but we also have scenes, local scenes and global scenes that you can also use to interact with your data. Panes are docked on either side of the views. And from the panes, you can use this to organize the layers that you're working with inside your views, also try to add other different kinds of data and so on. So the contents pane, which you might have referred to on ArcMap as table of contents, that's where you organize your layers. That's where you're able to set reference information and so on, also set the layer properties and so on. From the catalog pane, you're able to access and organize the different maps that you might need to use. You're able to also access and organize the layouts that you have in use and so on. You can set your default databases that you would also need to use within your project from the catalog pane. You're able to access also content from other sources within your organization, which you can bring in from your portal and be able to make use of them within ArcGIS Pro. So we'll just go into a quick demonstration of how this looks like. As I'd mentioned before, within the Pro application itself or on the interface, you're able to see the different tools from the contextual ribbon over here. So if I've selected, for example, I have my feature layer here on buildings, you'll see that I'm able to make adjustments to that particular layer based on the tools that have been enabled. If I had like a raster, again, those tools are made available, or we only get to access or make use of information that would be available or necessary to working with raster layers and so on. So within Pro, you're able to work with multiple maps, as I'd mentioned. So in this case, I have a map here of a university campus, and we have different buildings and so on, whereby the symbology is based on inspection dates. So for example, if someone wanted to do just a comparison between this particular map and maybe a map that is visualizing this information in 3D, then I'd be able to do that. So it just starts with, first of all, docking and making sure that my maps are both together in the same view. Then I can come and link my view. So that means, for example, if I want to focus in this region, then I have an integrated view or a linked view that allows me to look at probably which buildings need immediate inspection and what they look like and so on. So it will allow me to prepare and plan based on this ability to visualize and understand this information and so on. As I'd mentioned, we have the different panes. So we have the contents pane, but on this side, we also have the catalog pane docked here. Again, you are free to dock it on whichever location that you prefer. And from the catalog pane, I'm able to see the different maps that are available within the project, databases available, and the default database that I've set, and other folders available as well as any connection to the server I might have. I also have a direct access to my portal. So as part of the integrated system, I can access data that I may have published, data that is published within my organization, as you can see that, or data available within Living Atlas. So just beyond data, this means that I can also access tools and any other relevant content within ArcGIS that would allow me to make informed decisions using my own data. So after understanding all of that, maybe the thing we might want to see is how do we migrate to Pro, or what can be imported to Pro? So using the contextual menu that I'd indicated, we have an insert tab, and from that tab, we're able to import maps, layouts, and styles. So maps being your standard map document, your scene, or your local scene or your global scene. Again, you're able to add them within Pro. You're also able to import your layouts as they were and have them available for use within Pro. You can bring in your styles, and you can also bring in your annotations, both your database and map annotations. You're able to bring in models into ArcMap, the ones that you had as the ones using system tools, as well as any custom tools that you might have. In case you have scripts, you might need to make sure that they are usable within Pro, because Pro uses Python 3, and we have a tool that you can use to analyze and check your script to see if it's ready for use within Pro. So beyond what can be imported, as we have seen, there's still some items that might not be brought into Pro because we have newer and more advanced ways of working with this data, or working with these kinds of data and so on. So since Pro is advanced, we've also provided guidelines or ways for you to import some of these pre-existing data formats into Pro. We have tools that will seamlessly allow you to migrate them in. So when you're working with Pro, you're able to edit data as previously, again, similar as ArcMap. One of the easiest capabilities or things that you've enabled within Pro is that you do not need to start and stop an editing session. You just need to click on that particular layer that you're interested in editing, and then you'll be able to edit your data, both the geometry as well as the attribute information. And things that you've done within Pro to make your editing experience even better is that now we have project recovery that has been enabled, meaning that in case you abruptly or unexpectedly shut down your project, you're able to recover it. Also, we have options that allow you to automatically save your edits as you're making them, meaning that you continue to be more productive because you do not need to redo anything. You're able to do analysis within Pro, and we have all the tools that were available in ArcMap now available on Pro, using the tool set that was there, which you can access from the analysis tab and so on. Beyond that, you're able to use Model Builder again to create your models. But also, as I mentioned, that all the new capabilities are within Pro. That means that now all the new tools or all the new ways of doing analysis are within Pro. One of them is ArcGIS Notebooks, which is just built on top of Jupyter Notebook and allows you to seamlessly build your analysis, put in guidelines or steps that would in the form of comments that will give people an understanding of what is being done and how to go about it, and also provides a very seamless way of sharing it out for use across other interfaces and so on. So this is just an additional way of doing your analysis and sharing it out for use with other people. Lastly, you're able to do your mapping and visualization, whereby, as I mentioned, you're able to have multiple layouts and also additional things such as you have now SVG symbols being enabled. We have map series that replace data-driven pages, again, with more capabilities that have been brought into Pro. As part of mapping and visualization, you might also need to extend this towards sharing it into formats that are usable on the web. So we have a sharing tab. From there, you're able to share your data or your information or your maps as packages or web layers or even as web maps. So I'll just go into a quick demonstration again on how to do that. As I mentioned, we have the different tabs on the ribbon that you can use to do your analysis, do your editing, and so on, which you can see them there. If you're looking at analysis, just click on this tab. Let me just empty this layer. So for analysis, we have tools that are available. Again, you can do your own geoprocessing. From that, I'll just try and open it from this side. So we have tools that have been made available again from from ArcMap that were there. Some of them actually have added capabilities within them, but you also have new tools that are now incorporating things such as machine learning. So an example is the Geo AI tools that have been made available within ArcGIS Pro that can allow you to be able to leverage the deep learning capabilities that are available across the ArcGIS system now within Pro to be able to quickly get some information or quickly do your analysis. So these have been organized in 4 different tool sets. And for example, we can use the Imagery AI tools within this tool set to be able to extract features using AI models. So that means that you can either use your own models or you can use the models within Living Atlas together with this tool and be able to get information such as this. So from my image there, I'm able to run that tool and get an extract such as this. Again, the flexibility we have with some of these tools is that you're able to continue adjusting the parameters and so on to be able to refine your analysis and be able to get better results from the analysis that you're doing. When it comes to sharing, again, on the Share tab, we have different ways of sharing out your information. So if I had a map, a standard map, for example, I'd have different options for sharing where I can create my web layer, I can create my web map, and so on. I can even overwrite an existing web layer and so on. If I'm working with a web scene such as this of my university here, then I'd be able to share this out as a web scene. So once that is opened, I get my pin here for sharing. And from that point, again, I can enter the different parameters and so on, analyze this just to make sure that everything is in order and be able to share this out for use. If I'm looking at the different content, something that also I can be able to see what will be created anew within my portal, which you can see it's listed there, but you can see that I also have other layers that will not be created, but will be referred to within my particular website once it's created. So these are just some of the considerations you might need to have whenever you're trying to share your data. And within ArcGIS Pro, you can see that it's quite seamless when you're moving from your desktop environment and trying to create something for use on your portal, just making it available for a variety of users beyond the desktop experience. So with that, as I mentioned, we have a number of resources that you can refer to. So just we have different ways that you can try, different resources that you can refer to when you're trying to move into Pro. One of them, and I think the most important starting point, if you're starting your Pro journey, is to look at the Pro Migration Resources page. From there, we have guidelines on, again, what's the current product cycle for ArcMap, and you'll find the relevant tools you might need to help you get started with ArcGIS Pro. The other thing we have is we have some videos on our YouTube channel, which you can view some of the latest capabilities as well as quick tricks and tips on how you can work with Pro. We have made it much more easier to achieve some of the things that you've been doing, some of the workflows that you're following previously and so on. So the good thing about the videos is just show you some of those tips and tricks on how you can quickly navigate within Pro. On our documentation sites, we have tutorials available and also a series of tutorials available that you can use to understand how can you get started with Pro, how can you do analysis, how can you edit your data, how can you work with unique data sets such as utility networks of parcel fabrics and so on. So all of those are available within our documentation site where we have this information. With ArcGIS blogs, again, you're able to access the latest articles. You can get access articles on the latest capabilities within Pro and so on. We have books, the Esri community, where people normally share their questions or their experience on something, which provide an additional source of information in addition to what we have on our website. The help page on Pro, as well as training that you can get either instructor-led or self-paced in terms of learning how you can better apply Pro in your work. So in summary, we have seen the reason on why to use move to Pro, other than getting the understanding of how it is much better suited to work with your data. We've seen how it's easy to make use of the interface based on the contextual ribbon that's available. We've seen that you're able to work with your different maps and layouts within the same interface, making it easier to get insights and work with your data based on the format that you're looking at. We've also seen that it is well integrated with the ArcGIS system, whereby from your portal, you're able to access other data from your organization that's published within the portal or other information that's been published or made available through Living Atlas and so on. And we've also seen some of the features and enhancements that are currently within Pro, but also you'll be able to access others as they keep on coming into Pro. With that, I would like to thank you for this opportunity to share this. And yeah, I welcome any questions you might have regarding the Pro or the process of migration to Pro. Thank you.
Yeah, thank you. Thank you, Pauline. I think your presentation was so nice that there is no question at the moment. And if somebody is having any question, then you are welcome to ask that. I think Mr. Rajesh, yeah, Mr. Rajesh, you can go ahead, please.
Hi, Pauline. Good morning.
Good morning.
Thank you for this nice presentation. I have one question, please. It's regarding the sharing of ArcGIS elements to a web layer. Okay. Do you have any limitations on it? If in case I wanted to share a 3D object?
I thank you for your question. So we are currently, if you're trying to share your 3D items onto online or trying to publish them online, it is possible. So whenever you're publishing, we have the sharing pane, which will give you guidelines on what you might need to have available for your data before you publish it.
The problem
maybe,
is I can't export, I can't share more than 2000 elements. Whenever I try to share 3000 elements, more than 2000 elements, it's going to give me a warning telling that you can't share beyond 2000. So how do we handle this?
Oh, sorry. So you mean in terms of the number of...
Yeah, number of features.
Oh, okay. Okay, sorry about that. So maybe I think I will need to see, we can have a discussion about this after this webinar, but I would like to see maybe the kind of data you're trying to share and try to see if that's what will be bringing in the limitation. Because ideally, you should be able to publish your different elements online based on what you're trying to make available online. So I request that we connect after this, try to get a better understanding of your data and see how to help you publish all of it. Thank you. I'll just put my email address on the chat. Thank you.
Yes, thank you.
We have one more question, Pauline, from Mr. Selvaraj. So if you can go ahead, sir, please.
Yeah. Hi, Pauline. I have one question. When I open ArcGIS Pro, every time it's creating as a GDB file, right? It's as like a project, my project, like that GDB file it's creating. So what is the purpose for that GDB? And how I can, if I want to open in another PC, like same this system, I have to copy all things to that system to open this file, or what is the purpose for this thing? This is what.
Okay. Thank you for your question. So how Pro has been put is that we have a project, and within the project, you might want to have everything that you need for the particular kind of work you're trying to do. So by default, it's going to create a geodatabase. It's going to create a toolbox where you can put in tools for your project. It may create other different components that you can access within the catalog pane. So the purpose of this is just to help you be able to organize everything within that project to be accessible there. It's just a default component of Pro. However, if you would like to use the geodatabase you might have previously, you're still free to do that. You're able to add it to your project and set it as your default geodatabase. And the one that was created previously will not be in use because now you've changed your default geodatabase to be the one that you prefer. So you're able to do that. You can also go to the settings of your Pro, of the Pro application on your machine and try to maybe configure how whenever you launch Pro, what can be created and what maybe does not need to be created and so on. Maybe again, if you send me an email on this, I can be able to share steps on how to go about that. But ideally, by default, it will create some of these elements or some of these components for a project, such as a toolbox, such as your geodatabase, but you're free to switch and use the ones that you have previously been using. To the other component you asked about, do you need now to move this information, such as your database and so on, to a new machine when you're using it? I would say that that would not be necessary because, for example, if you had your different components being made available from a shared server, for example, or a shared folder, you'd still be able to access it from that. So you don't need to move around your geodatabase. Also, if it's being made available, if the data is being made available as a service, that is as a feature service, again, you're able to access it from your portal or from your server and make a use of it from there. So you might not need to copy or create different copies of that same data. You can use some of the best practices that are there generally, either as having these geodatabases within a shared folder or within a shared server, or using feature services as a way to access and make use of this information. Yeah, I hope I've been able to answer the question that you had.
Yes, Pauline, yes. Thank you. Thank
Okay.
you.
Thank you so much.
Yeah, thank you, Pauline. Thank you very much for this presentation. And we have seen that this ArcGIS Pro is going to be like more efficient, more productive. And it is having like project-centric approach, which keeps all our maps, 3D scenes, layout, tools, geodatabases, and connection in one place. And that can be used efficiently for exploring, visualizing, and analyzing the data in terms of information for a particular project. So thank you so very much for giving us this hope how to go from ArcGIS map seamlessly to ArcGIS Pro. Thank you so very much, Pauline. Now, last but not the least, our presentation is from Mr. Aduri Srinivas. He's our strategic project head, and he's going to talk about the various platforms which are available for digital twin. And Mr. Aduri Srinivas is working here in Microcenter as a strategic head, and he has around 28 years of experience in enterprise GIS, software development, utility and GIS data mapping, a smart city, BIM and 3D photogrammetry. Moreover, Mr. Aduri experience is in various roles, including system architect, client engagement and project management, and services delivery. He has served and delivered projects for global markets such as the USA, European countries, Southeast Asia, and the Middle Eastern region. Mr. Aduri is also certified from Building a Smart USA as a project management and certifies as Information Management Practitioner, BIM, according to ISO 19650. He is also a technology, friendly person, and he has got certified in machine learning and blockchain technology from IBM. So without taking much time, I'm inviting Mr. Aduri to, delve us into the concept of digital twin platforms which are available here. So Mr. Aduri, please go ahead. Yes.
Yeah. Good afternoon. I'm Adiri from Microcenter, working as a strategic project head. And it is my pleasure to be a part of this GIS Day event. And I'm excited to discuss about the digital twin platform for the buildings, roads and infrastructure development. Regarding this project for digital twin platform, and I would like to give some of the outlines here. I'm going to discuss about the objective and what is the digital twin maturity as per the level of collaboration, and what is an open BIM, what is an importance of IFC, and I'll also discuss about the GeoBIM ecosystem data flow and mechanisms, and what is the digital twin viewer and what is the next twin platform and why it is useful for the AEC industry. And I'll also discuss about the web-enabled 3D interactive viewer for BIM models and what is the requirement for the AI-based artificial intelligence-based for BIM models and what are the filtering checks that can be go through this open BIM platform and integrate your GIS and IoT ecosystems with your BIM model and some more details that I would like to discuss. Now, what is an objective? The government organizations and AEC engineering companies or even other infrastructure development sectors are working with different kind of data formats and standards and methods. So during the construction stage or at the design stage, need to unify all the stakeholders because of different data standards are following in between the government and AEC engineering companies. So that is where the common standard arises. So by centralizing the data and establishing a streamlined workflow, stakeholders can work together by creating a centralized hub for data exchange and collaboration. So that is where the Open BIM digital technology platform empowers the stakeholders to work together effectively. Now, digital twin, might heard about that, but I would like to give some more glimpse about digital twin here. A digital twin is a dynamic update representation of a physical object or a system with a complete collection of all of data in one place. So digital twin is a dynamic and up-to-date representation of a physical object or a system or as a processes, a collection of all data in one place. So digital twins have emerged as a transformative technology with applications in the various industries or sectors like smart city, building permits, or even manufacturing, engineering, design, healthcare, etc. And furthermore, digital twins find valuable applications in the permit systems because by allowing the authorities can visualize the proposed construction projects in a virtual environment. So the advantage is like by implementing the digital technology, the quality assurance and quality control can be maintained and real-time remote monitoring is possible. For example, if you integrate with the GIS, BIM and IoT components and taking that IoT protocols and better team collaboration, for example, engineering departments and as well as government entities, they want to maintain a standard common data between the construction AECO companies and as well as organizations. Better team collaboration is very, very important that I'm going to discuss probably in the next slides. Now, the maturity digital team from where the journey started. When there is no BIM dimension, let's if you take a level O or stage O, stage 0 level, starts it in the 90s like no BIM dimensions. It started only the primary level, which includes only the 2D CAD drafting. It's a low level, it's a low collaboration. So 2D CAD drafting as in computer aided design tools as drafting has started in between the departments. And there is no combination of BIM enabled software. I'm talking about in terms of 1990. Then slowly the stage one has come. That's a partial collaboration. This 3D CAD models has come up, integrating the component of 2D drafting. So the collaboration is increased within the internal departments and organization itself and the 3D CAD models. So the 3D CAD models and the 2D drafting documents has come up in the stage 1. It's a for architectural point of view, or a drafting point of view. Next stage started is in stage 2. That's a level 2. It's a full collaboration. This level, which operated by the collaborative process, means maintaining the IFC. For example, industry foundation class that I'm going to discuss in my next slides. So how do you share the IFC data between the construction companies and the government entities? And what is an IFC data? And what is a COBI? COBI is a construction operations building information exchange. So these two data sets are transforming the data between the different stakeholders to maintain a full collaboration in the BIM. And again, in the stage 2, there is another term called CDE. That's a common data environment. That is also a part of your digital twin maturity as a journey, as a collaboration. The next stage started with the digital twin. It's the next level to the BIM called a digital twin technology. So the digital twin is a full collaborative process. It's a full integration process, and this allow all parties to access the project as a paperless project based and a cloud based data that has been extended to the execution. So it comes up with the simulations and cloud collaboration where you can keep all your IFC and BIM model in the AWS cloud platform and synchronize the data from your local machine to the cloud platform. That's the next stage of BIM where the digital twin started. So that's where the open BIM has come up to maintain a unifying like a common data environment. And again, real data components. For example, identifying some IoT components to the BIM and what do you call the GIS components. The digital twin is an additional layer on top of the BIM to see the real-time data by simulating the BIM model. So system integration is also is one of the component of the digital platform. And the next stage is the 4. Stage 4 is the metaverse. Of course, metaverse is still in its early stage of development, but it has a potential to transform the construction industry. The BIM and the metaverse could be used to improve communication, collaboration, and effectively through the project life cycle. Of course, I'm not going much into this metaverse, but on top of it, NFT like a non-fungible token, and as well as in blockchain integration with the metaverse and AACO, industrializations and virtual reality and augmented reality. These are all comes out as a part of metaverse. Now, what is the transition from 2D and again 2D to 3D and again 3D to digital twin platform? If you look at this, a digital twin relies on a number of layers of the data that build on top of the layer. For example, if you take a layer 0 as discussed in the previous slides, it's a plain terrain based as an information as a 0 level, taking your CAD drawings and GIS data and scanned urban plans, etc. On top of it, 3D models and buildings has come up with the 2D data sets. So that's a building. Now go to the next layer 2. Again, infrastructure has come up. The infrastructure is like in roads, bridges, and utility, keeping another one as another layer. So this is the transition model, right? So if you go to the next one, layer 3 is on mobility. So sensors across the urban landscape, traffic, all these are all the integrated component. On top of it, the layer 4 comes. That's when virtual smart city comes. So it's a collection of data from 03, as mentioned, like 0 to 3 is from sensors data, IoT, and connected devices, vice versa. So this is to centralize and analyze the gathered data manually or even better automatically. So this is the virtual smart city comes from 0 to 3 and adding your IoT data on top of the layer 4, making us a virtual smart city. Then what about the virtual digital twin? Coming up all up to 0 to 4, taking the 0-4 layer and push into the layer 5, then it becomes a virtual digital twin platform where you can simulate and send results back to the real world. Now, Open BIM. We'll talk about the Open BIM and industry foundation class of the IFC Smart City. Okay, Open BIM refers to a common language and a set of standards, allowing architecture, engineering, and construction like an AECO teams to share the information regardless of the preferred software. So users can export their data into different file formats like an IFC, Industry Foundation class, or BIM collaboration format. That's called a BCF. Now, In the internationally, the current version is on 4.2. That's the most supported and stable format recommended from the Building Smart organization. Okay, so IFC schema specification is a primary technical deliverable of Building Smart. So it's an open standard format, as I explained about IFC schema to promote the open BIM technology. Now, 4.3, it's still not yet released officially from Building Smart, expected to release sometime in the first quarter of 2024. This is an extended infrastructure project. The IFC 4.3 has come after 4.2. Under 4.3, it comes like in roads, railways, even geotechnical alignment and ports, etc. It's an extended infrastructure projects IFC 4.3. 4.3. Now, if you look at the global perspective view, IFC adoption is already implemented in the United States, Canadian region, Southeastern region, and recently, if you look at that, digital BIM model submissions will be the mandatory and building permits in the Dubai, starting from 1st January 2024. The IFC format Open BIM is officially declared that Dubai municipality is going to use it and already they implemented. Now, this is a very interesting slide. I like it really. So I would like to share about this slide on GeoBIM ecosystem. What is the data flow and the mechanism? Let's take an authorized tools starts with the Revit. We have a Revit format. We can take the RVT file even from Revit, Autodesk software, even Tilka, etc. Now exporting this Revit and the output of BIM and Revit model, taking it to the IFC. Okay, and again, the data owner has come up with different standards like in point cloud data, LiDAR scans, or even raster vector scans, and integrate the your BIM and Revit model to the third-party GIS services. You can have a scanned drawings or even IoT, the format and sensors. And again, they may have their metadata like an Excel and a CSV, where you can transfer the data between the stakeholders. Of course, even 360 panoramic, all these things is you can push into your BIM submission platform. BIM submission is not only for the building permit. The BIM submission platform could be for the road or infrastructure development, as we talked about on 4.3. So the BIM model visualizations and QA process, common data environment, whatever I given in the flow chart, the architecture, this can be implemented in the BIM submission platform. And again, the entire the combination can be integrated to the RGS enterprise environment, and even RGS Pro supports exporting that IFC file from Revit to RGS Pro. Even 4.2 is also supporting IFC in RGS Pro. So, and again, you can integrate with the third-party component. So you can integrate like an Open BIM API and even RGS API that I'm going to discuss in my next slides. Now, what is a Nexus Twin? It's a digital twin platform for centralization of different data sets and data formats. And using this platform, digital twin platform, it's a full-blown GIS environment where you can collaborate with them and you can upload the BIM models and create the digital twins and go ahead on the AI-based BIM model and filtering checks on it and integrating the IoT component. And there are certain engines from BIM to GIS and the GIS to BIM, vice versa, and the data overlay from BIM to GIS area. So I'll be discussing more about on the individual models in my next slides. Now, what is the Nexus Twin digital platform here? Nexus Twin platform represents a shared system between the permit applications and permitting engineers that streamlines the BIM model submission, validation, review process. So with this platform, there are certain inbuilt tools. User can visually inspect each project model individually in a 3D environment, either individually or together combined with the georeferenced digital environment. Using this platform, user can push even drawing files like a DWG, GIS, IFC, point cloud data, raster data, and IoT. And user also can retrieve the important data from using this Nexus Twin platform and enhance for their decision making for any for the AECO industry. And interestingly, we can integrate the Open BIM API with the RGS API to interact the 2D feature layers and 3D web scenes. Now, the web-based 3D interactive BIM model with this Nexus-10 platform, inbuilt tools, user can browse and visually inspect the BIM model by structure-wise, floor-wise, IFC class-wise, and set it by element types. For example, user can view the IFC models and inspect the model issues and create BIM collaboration format issues where they can exchange that information and create the BCF issues. I'll discuss about the BCF issues in my next slides. Now, what is a full-blown GIS environment? In full-blown GIS environment, users can combine all BIM models into 3D georeferenced federated model and overlay it with their existing GIS datasets for powerful GIS spatial analysis. Visualize the 2D data and the 3D data. And again, interestingly, the stakeholders can view all projects in a digital twin environment with exact and precise geographic location, or in a full-blown GIS environment where BIM and the GIS data overlay. So the backbone of this platform is a full-blown enterprise GIS environment built into this solution and available for usage as a server tool for GIS data and broadcast. So data sets can be imported from BIM model and automatically from BIM to GIS. That is also possible to transit the data. Now, what is the role of Nexus Twin in building permits, construction, and infrastructure for the submission? User can start upload the OpenBIM IFC files in the Nexus Twin platform from different asset disciplines. For example, MEP, HVAC, or even infrastructure related any federated any federated model. Okay, so here, I mean, so exporting the BIM model to IFC is one of the most significant step, because the RVT file cannot push straight away, because to maintain the open BIM standards and IFC transiting the data into the IFC is one of the significant step that should takes place before uploading the model to the BIM platform. So while upload using this Nexus Twin platform, the BIM get georeferenced all kind of point cloud data, and even DWG file or even IFC file also can be uploaded, and it can be pushed to this BIM platform. Here I mentioned about a federated model. So what is a federated model? A federated model is a combined building information model that is compiled from several BIM models from different disciplines into one platform. That's an Nexus Twin. Now, what is a conversion process? If you look at that, number one is the conversion process is user can upload DWG file into the Nexus Twin platform. And again, using the 2D drawings also, they can go for the code valuation, code compliances also. After uploading the DWG file, user can view the results as a code compliance checks. And again, automatically the DWG file can be automatically creates GIS data on fly and automatically creates a BIM model out of the parsed data. So this model is for facilitating a full 2D to 3D conversion process. The show starts with the upload of DWG drawing, which then gets the taken over the parsing and automatically creates the GIS data out of it, imports them into background of the relational database automatically, and creates the BIM model out of the parsed data. Now the conversion of BIM to GIS, and again IFC georeferencing and conversions. The conversion workflow is a straightforward. It relies on the OpenBIM IFC standards and banks of the custom built BIM to GIS engine that has built in the BIM business logic as well as GIS mechanisms for the conversion and georeferencing. So if you look at this steps from BIM to GIS, the Revit exported into IFC, And again, the mechanism of the engine, BIM to GIS engine starts and exporting into the BIM to GIS as such. And again, it starts giving a background relational database is also maintaining, of course, using Esri database is also happening there. And again, push into the RGS environment and publish the RGS REST services. So this data conversion engine can export into the GIS different data formats like in GeoJSON, Esri shapefiles, or even a file geodatabase and KML, vice versa. Now this is very interesting, like BIM collaboration format. The BIM collaboration format, it's a structured file format suited to issue the tracking with building information modeling. Now, I find some issues after my class detection, after my run results. I want to share these results, error results to the engineering department. So I can use the BCF format as a structured file format. So here that's what I just try to give in. Like for example, using this BCF format for tracking issues or sending comments or marking up, between the project members, you can push that information, send back results to the contractor from the engineering team. So based on the unique ID and storing of views and location of the issue also can be taken straight away from the BCF. So by going through the issues of BCF will direct you to the specific location. That's most important, and identify the BIM model. Now, centralized collaboration and Nexus Twin platform is it's the stakeholders can work simultaneously in one centralized digital twin platform, and they can communicate effectively by creating issues as a BCF file. So all issues can be tracked and managed with using the issue management. Issue management I'm going to discuss in my next slide. Now, different civil engineers or even plumbing or AECO team for the same building can also communicate, and they can export the BCF data with the common, with the comments and send it to the BCF format and send it to the respective engineers and contractors. Now, design calculations and documentation. Design engineers can improve their workflow by driving design calculations using design calculations tool that takes information directly from the architectural BIM models. This approach also creates a consistent and comprehensive documentation extracted from the BIM model. Okay, for example, the idea here is to enable end users with the very quick look, like just click on that and preview the uploaded BIM model design. And I want to check what is the gross floor area and how it can be calculated. And how many number of parking places are there. So this is exclusively useful for the design engineers, before the construction. So design engineers can effectively use this module, and they can see the, quickly they can see automatical process, and they can see the calculations in one time. Now, AI-based BIM model filtering and checks. The Nexus Twin is integrated with the GPT-4 API and is harnessing power of OpenAI. So users can search the BIM model through direct conversational request into BIM model filters and checks. Okay, let's take an example. Find all doors higher than 2 meters. This conversational request is translated into the code in background on the fly, and that code run over the data model that the results are automatically visualized and view in the BIM model. So do you want to say, would like to find all the doors in the BIM model that are made above the wood? So this is the screen here. So the query can push into this. A query is to find all the doors that are higher than more than 2 meters. You can run these results and find out the results. So real-time filtering and BIM model search through the direct conversation request translated into the BIM model filters and check through the power of AI. Now compare the BIM models. Now what is the comparison? With new version, the new version, older previous versions also can check and track and historical data also can be find out, and they can compare the versions. Now issue management, again the same, like detector, like in class detections, results can check, and they can issue the they can send it back to the ECF, and all the stakeholders can go through the BCF format and manage the issue management module. Now interestingly, this is a water retreat infrastructure connectivities also. For example, topological integration BIM and GIS. So the geospatial and geometric data contained in a building information modeling and water distribution network models can be used for the integration. Okay, so the GIS utility service connections with the IFC to validate the data based on the corresponding geometry. So validations can include the checks for correct connections. For example, point wise or floor wise or level wise or adherence to predefined regulations of the building permits. So the model quality assurance, I'm not going much into this, the time is very short. So there are basically two kind of issues are there for the model. One is a model health issues and the design issues. And I'm going to show one slide that is towards an exit pathway and exits requirement path. So basically there are two kind of issues, model health and design issues. Now design issue, for example, like the right side screen, I want to see the emergency exit route. What is the distance emergent route from the main door? So like exit path exceeds required maximum length. So run combine check also the possible can run the model quality checks between the 2D and as well as 3D and measuring the length from the door to the staircase and find the regulations, and again opposite areas of window checking and material energy efficiency regulations, etc. Now point cloud also can upload the user into the distributed platform, and it can be automatically georeferenced and run from the point cloud file data. Now this is apart from this, Nexus Twin also supports for the road and infrastructure projects, and again bridges and infrastructure also to the photorealistic data. Nexus Twin has the capability of visualizing both point cloud and photorealistic 3D tile sets data obtained from through the drone and LiDAR data scans, and you can visualize the photorealistic data capturing, including the bridges and infrastructure in the Nexus Twin platform. Now BIM and IoT integration. Okay, fine. By integrating IoT readings and GIS data sets, yes, organization can definitely see the utilization and integration of the data in a distributed platform by integrating IoT components and BIM models to the distributed platform for the ongoing maintenance and real-time monitoring and structural health and performance assessment. Okay, so thank you very much, and this is my last slide. I'm sure I finished within the time. Thank you once again.
Thank you very much, Mr. Abdul. Anyone is having any question? Then please you can ask. I think there is no question. So that's great. Okay. So now finally, it's time to say thank you very much to all of our amazing speakers, wonderful audience, attendees who have taken all their time out for this day. And this GIS day was full of exciting sessions that helped us to look into the present and of course the future prospects of technology in BIM, digital twin, Esri BIM collaboration, that is mainly, they talked about Autodesk and construction cloud. And, I especially want to thank Mr. Aduri when he talked about, the B2B to B2B to C. That means like what BIM was there, then it went to digital twin and how it is going into the metaverse platform. And he discussed in detail about the Nexus BIM platform. And of course, it was a great, immersive experience as far as the platforms of BIM is concerned, and basically digital twin platform is concerned. So I believe that these technologies are going to help us in achieving great efficiencies, and that can be done by these technologies. And now I would like to thank our organizing team, that is Mr. Aduri Srinivas, Ms. Gigi, Ms. Nimisha, and other supporting staff. And we all are going to meet again in person for our 40th year celebration that is going to come very soon. And all of us will be invited there, and we look forward to see you very soon. So finally, I would like to congratulate all of you on the occasion of National Day. And this National Day will bring peace, prosperity, and success in our lives. So have a great day. Thank you so very much, all of you. Thank you.
Thank you.
Thank you very much. Thank you for all the participants. It was great presentations that we viewed. Thank you very much.